Kanpur. He has worked as a faculty member at NIT Jalandhar, the Hindustan College of Science and Technology, Mathura, and research associate at Department of Metallurgy, IISc Bangalore, and a visiting research associate at IIT Kanpur in summers of 2004 to 7. He also worked as a visiting faculty of Department of Management Studies at HIMCS Mathura. He published 2 books and more than 115 research papers in international journals only. The total value of R&D projects and STP course under him is approximately 100 lakh. He has the life membership of Indian Society of Technical Education and Indian Society for Advancement of Materials and Process Engineering, and a fellow of Institute of Engineering India. He has also the membership of International Society of Impact Engineering. He has guided 12 PhD students as a sole guide or a main guide, and presently he is guiding 8 PhD students. He is also a reviewer and member in an editorial board of national and international journals. He has visited Stony Brook University, New York, USA, and a material testing center, ULM, Germany. He has been invited for the talk at a Department of Mechanical Engineering, IIT Roorkee, Government Engineering College, Bhagalkot, Karnataka, AR, ADRDE, Agra, NIT Jalandhar, MSRIT Bangalore, and BIT Sindri. He is closely associated with the field of composite material for the last 8 years. He has received the N.K. Iyengar Award in 2014 for his research paper from the Institution of Engineering, India. Canara Bank Research Paper Publication Award for the Department of Mechanical Engineering in the continuous 2 years, 2016 and 17, at ISM Dhanbad, and Best Research Paper Award in an international conference at a Sikkim Manipal University 2017. His area of research in advanced nanocomposite and advanced manufacturing and fracture mechanics and micromechanics. Thanks, sir. It was my pleasure to speak some few words about you, sir. Welcome to the FDP, sir.
Thank you, Abhishek, for giving the nice introduction about me. I am working in this field around, I can say, the last almost 20 years in the field of composites, and rest of the things you already told about me. So that coming 2 hours, you will find out what is my knowledge in this area, how much I have learned in this area, and still I can say every day is learning process. When you come to the department, definitely we have to sit sometime in the lab and see anything new is today for me or not. So this is the positive approach I am working, and I am happy to inform you the outcome of the total awarded. Now I can say the 13 PhD is awarded under me as a sole guide or man guide. One of my PhD student recently joined as a faculty member in IIT Madras. Other PhD student is working now the uh, faculty member in the North America, and now the 4 PhD student is doing the postdoc in the different part in the international university in USA, Austria, and Germany. And India, our PhD student now the faculty is the government engineering college in the Pune and military engineering college Pune, and few students also the professor and dean in the Noida, some of the private good universities. So the output of this PhD and the research is like that. And before going to the directly to my talk, just I want to inform you the outline. And before that, I have one announcement. Currently, I have the 3 vacancy for the project fellow. Two advertisement I'm giving to just tomorrow or day after tomorrow. For the project associate for the 2 years, we have one Coal India project for around 72 lakhs. One more project we have for the taxman, and one more project we are going to receive very soon. So we have the 2 vacancy, that is tomorrow or day after tomorrow, and one more vacancy in this month in based of the composites. And also, if you know the any software like the ANSYS and other things. So before going to the original talk, I had designed my talk in that manner. So 2 minutes, I am giving the introductions about the showing some video, a small clip of my institute. Then we'll start from the basic of the composite. So we'll talk about composites. Then we'll talk about why composites. I'm sitting in the coal capital of India. I am talking about composites. So then we'll talk about, show you some of the video at the last of my talk about what exactly we are doing in my lab in the IT ISM Dhanbad. Okay, so we start from the first video, then my lecture, then the second videos. Are you able to see this?
Yes, sir. Yes, sir.
Yes, sir.
कर रहा है ये?
Yeah, folder is open, sir.
Yes,
हाँ, okay. Please just see the just information from my related to my institute. Because my institute I have the All India ranking in NRF 11. So we have just missed rank 9. I think 0.6 due to 0.6 percentage we can say. So we have to show this institute, see the facility, and see the history of my institutes, and now where we are.
Okay, sir. Video is not open, sir. Till now.
It is not open.
Yes, sir.
Is open? No.
No, sir. No.
No.
No, sir.
No, sir.
First share the sir. You share, sir, screen, then.
Yes, yes, yes. एक minute. Just a moment. Now it is visible. Now I set the screen.
Sir,
Are you able to see my shared screen?
Yes, sir. The screen is visible, sir, but video is still not playing, sir.
video पे मैं अभी play कर रहा हूँ इसको. Just a moment. Now it is playing.
not now, sir.
It is still not playing.
Yes, sir. Not playing, sir.
Not playing. Sure.
Ravinder, if you have that content, I think you can share.
Yes. ऐसा करते हैं तब पहले लेक्चर शुरू करता हूँ बाद में वीडियो.
Okay, sir.
ठीक.
सर कैन यू प्लीज
हाँ बोलिए.
जो आपका विंडो की है ना सर,
हाँ
उसको दबाइए और पी दबाइए सर.
P.
हाँ, उसमें राइट साइड पे आप विंडोज, उसमें एक आएगा कि वहाँ पे डुप्लीकेट।
अच्छा, एक मिनट।
वो 2
एक
स्क्रीन
बार,
में जा रहा है सर, इसलिए वही प्रॉब्लम।
अच्छा, एक मिनट। Justice. Now it is visible.
Sir, not actually screen. Some screen is visible, but not clearly shown.
Still, it is not visible.
Not no sir.
No.
No sir.
एक मिनट, इसका क्या हो रहा है?
सर आप पहले शेयर कर रहे हैं सर स्क्रीन, उसके बाद ये खोल रहा है क्या सर?
हाँ। Present director Professor Rajiv Sekhar, past director one of the alumni had given 10 crore of rupees to the institution. 1926. Yes. So now this is the introduction about the institute. So पहले खोलना पड़ेगा नहीं? You have to open it here. Then you have to go for share. Yes. So
Yes.
now my screen is visible.
Yes, sir. Visible.
Yes. Thank you. So now you can. Okay. So sorry for the interruption. Actually, we are teaching on the different tool, the BEVEX. This we are not using at all. So this is the second time I am using. Sometimes meeting with the DRDO. So now coming to the subject. So here in the coming 1.5 hours, we will talk about the composites. I have told you initially why we are talking for these composites. I have taken this topic for the today's lecture, why we are talking for these composites, and especially for the mechanical testing of the composites. See, what are the decision is taken by the government. Maybe some people will talk for the political reason, but sometimes they may not be correct. Sometimes there is some scientific reason also. Suppose so we will find out the uranium is going to available in one place, but the nuclear power plant is associated in the different part of the country. Many of the times we thought that government is taking advantage for that, but there is some scientific reason for that why government is doing that. I'm giving one burning example for that. If you see the international market scenario, the coking coal, the good quality coking coal is available in the Jharia mines. To see about, but still government is exporting those coal. Then people can say once it is available in India, in the Jharkhand, in Dhanbad, in Jharia mines, even though government is exporting those things, because we do not have the awareness for that. Coking coal have the limitation in international market. So once we are producing our coking coal from this Indian scenario, we have to preserve it for what? For metallurgy. So we should not dependent every time on the foreign export. So we have to preserving our coal, and some part also we are using, but sometimes we are taking it from the other country, and simultaneously we are using our. So it will go for the long times. The coal is available in our countries. The good quality of coal that is associated, especially in the Jharia mines area. So if you see about these are the things, the material is available with us. So once these materials available with us, even though we are talking for the composites, nanomaterial, and so many things, the reason is because this is the man-made materials. This material we can make many times and we can destroy, but coal we cannot make in the laboratory. Okay, so that are the natural resources. So we want to preserve those natural resources. The answer is composites. The answer is multi-wall carbon nanotubes. The answer is the aluminum foam? The answer is new variety of the materials available, or we can produce, or we can make in the laboratories. So to preserve those natural resources, we are giving our research focus in terms of the man-made materials. So the answer is composites. So here, this talk will conclude in that manner. About we see about the introduction, literature review, material fabrication, experimental procedures, result and discussions, and conclusions, and the number of publications, especially from the impact side of the composites. So why we are talking for this? If someone will talk about the composites, if you talk to that person, if the many people will think about composite is nothing but the combination of the two materials. Here I will talk in that manner. I do not know about the type of the listener, but I think even though some new students, he do not know the definition of the composite, I am putting in his mind about him. And also if some of the learned faculty member also in this meeting, at least at the end of my talk, he can say, yes, we got some information in terms of the composites. So I have designed my lecture in that manner. We'll start from the basic and we'll go up to research level. So everybody who is putting his time and sitting in this meeting and listening me, he can say at the last of my talk, yes, that talk was fruitful. So you have to just wait and see for the coming 1 hour. So whenever we'll talk about composites, we have to see about, we can say here the material is loaded, and once the material is loaded, who is taking the load? Most of the times, if you see about the introduction to composite material by Hull and Klein, it is very clearly it is written, load is initially taken by the matrices and it is transferred to the fiber, and finally load is taken by the composites. If you see about your buildings, where you are sitting it right now, you can see about the concrete is there, the rod is there, and also cement is there, but finally beam is taking the material load. So that means we cannot say the only the iron rod is taking the load and only the cement is taking the load on all, or only the concrete is taking the load. So when we talk about what you talk for me as a human being, I can say for biomaterial for me. If you see the hand of the human being, I can say this hand is completely associated with the muscles and the bones. So if you see about these two, the combined it is taking some of the strength and taking some of the load carrying capacity, and we can say you have some strength in your hand. So if you see about basic fundamental about what is composites, once the material is loaded, load is taken by the matrices, and again it is transferred to the fiber, and finally composite is taking the load. So fiber reinforced polymer composite, a combination of fibers and matrices, okay, and where the works as the reinforcement agent while matrix as the bonding materials. Matrix reinforcements, and finally we are making the composites. Why composites? Advanced over traditional materials, high strength to weight ratio, aspect ratio is good. Wide application as advanced material in industries like aerospace and aircraft, marine, automobiles, etc. You can see this. Then also we have the very good design flexibility. I feel that sometimes many of the students is sitting here. So sometimes I'm just entering towards the subject and talking some of the basic fundamentals of the materials. Whenever we are standing in the class of material science, we are talking about it is moving from the austenite, bonite, and cementite, and then we can see about the FCC, BCC, and SCP. And we can talk about when this type of the information we are getting, finally as a mechanical engineer, our duty is to understand the mechanical properties of the materials. That is our duty. If you see about the broad area of information about materials, you cannot do the research. Once you want to do the research, you have to focus on what is the mechanical behavior of the materials. And that times you are talking in the iron carbon diagrams and about the austenite, bonite, and cementite. So whenever we talk about all this, finally, what exactly you are getting? You are getting some of the material properties improved, some of the material properties, it is going to the decrease. What exactly you want? Well, if I can say about, in my personal opinion, I can say about mechanical engineering is the best department. From I can say from my school days, and now I'm faculty in Department of Mechanical Engineering. Because you can do the design, you can do the manufacturing, you can sell it in the market, and you have the choice what you want. If you want to improve one of the mechanical properties of the material, you can do it. You can design it, you can learn some software, and you can design it. See, my dear students, whenever all these facility with the materials, even though one thing we are missing there, if you want to make a good product, you want to do a good casting, we have to go for the very good quality of the casting, investment casting, and all these backslash methods. Lot of flexibility you don't have. Lot of flexibility you don't have. You need the flexibility to work here. The answer is composite here. Whenever, it's my experience, I started my journey from Taneja Aerospace Industries and DRDO and NIT Jalandhar and ISM Dhanbad. You have to see my profile. If you see the industries, many people who is, if you are talking for the materials properties, who is happiest person? Happiest person is the designers, because he can design the new product once you are giving the new product to the market. If you remember, 10 years back, 15 years back, when I was a PhD student, we have the floppy disk. We have the floppy disk, 32 MB pen drive is still with me. Okay, so now you see how much pen drives with you, 64 GB or 120 GB, whatever the pen drives with you. Can you think for the materials? What is material for that? How this much data storage with that materials? What is happening behind the materials? Who has improved this? Now, if you see about the small things from your surroundings, and if you see about what are the information, these are taken from your life is become very easy. So what exactly you want? You want to have see the once in the 1987, 89, I was a +2 student. We got a new watch and very happy. Yes, कॉलेज चला गया, एक नया घड़ी मिल गया पापा की तरफ से. We are very happy to see that. अभी क्या हुआ? आपके हर एक मोबाइल में एक वॉच है. So see the transition of this technology. Now my giving this all this information to you. Now once you want to make some of the product, we need a good design. For designing, we require a good materials. So the design flexibility should be there, and that we have in case of the composites. So we can say about composite is nowadays, it is going to be used in the aerospace industries, automobile industries. If you see about a car, the present car, the 10 years back or 15 years back, see the body of the car. See the one car from the one company and other car from the other company. See the cost of that. See the impact strength of that. And nowadays people is talking about ABS1 and ABS2. So whenever these are the things in front of you, okay, see, I'm sorry to tell you, my PPT to ek tarika hai dikhane ka kuch information. I can speak in this area continuous 2 hours without looking the PPT. Okay, it's very this area is very close to me. Okay, so because once you're showing the PPT to make more interactive, so I'm showing some of the PPT. So whenever we talk about some of the new cars and old cars, see the materials. What exactly you want to save material? You want to save design? What exactly you want? You want once the driving or some mistake takes place, what will you at least you want to save your life? Who will save this life? If you have the good material, good impact strength of that materials, you can say take the example of the 2 cars from 2 different companies. Okay, I don't want to say the name of the company, otherwise I should not advertise some company. So see the cost price of that, see the quality of the materials, see the quality of the materials, see the impact strength of that, see the fatigue strength of that. So once see the impact strength, see the fatigue strength of this, then you require giving the good design to the new shape in the industries, in terms of the car market, in terms of the complete automobile markets, or in terms of the aerospace, or in terms of the rail industries. Who is giving all this flexibility? By using the new advanced materials. So in this composite, not new materials, this is not started yesterday. So once a people is working composites last few years back, we can say what are the additional things we are able to do it. So design flexibility should be good, and also we are getting the better result. So see the area where people is using nowadays of the many of these cars, these new cars, and the good design and ABS1, ABS2. I hope you understand as a mechanical engineer. So once you have about all this information, our design flexibility, our quality of the design, surface of this material should be the better compared to the earlier ones. Answer is the composites. Who will motivate this? You see this information about this. See this information. This last corner, this is the one car from one of the company in my campus. It was accidented, and now we can repair it, and we are not able to find out how it was earlier ones. See this. Once you are talking about flight is taking the takeoff and it is landing time. Some of the bird is hitting that, and we can say, see the news. Yes, thanks God, today flight is safe. So what you have to do? Tomorrow morning we have to throw this flight. This flight is not able to work. Yes, this is not a question now. We can say about those are repairable. We can repair it. There is some technique for that. So see the market situation. In the automobile, in the marine, or in the aerospace industries. We can say about, see the design flexibility of that, and we are using nowadays composites, and we are adding to that composites is some of the more good quality of that, better quality of that. See if you talk about the aerospace industries, like about the this, I can take one burning example from the India, BrahMos missile. What is the material for that? Carbon fibers. So how we can improve the strength of the carbon fiber without increasing the weight? This is a challenging job in front of us. If you see about the Bell Helicopter Company USA, they are also using lot of related paper related to composite paper from my research. Always we are receiving the mail from that. They want to improve the strength in terms of the mode 1, mode 2, and mode 1 and mode 2. Because I hope you understand about mode 1 and mode 2, opening mode and sliding mode. So whenever we'll talk about fiber reinforced composites, we'll talk about the mode 1 and mode 2. That means opening mode and sliding mode. Material is going to fail by the mode 1 or mode 2. So this type of the information, 3-point bend test, also nowadays we can, very popular, we can use this and for the new design of the materials. So this slowly I am talking from the basic, from the composites, and moving towards, because in the, if you see about the complete the research area in the material testing, we are working on the G1C, G2C, machining, impact, fatigue, tribology. There are so many areas we are working with the different group of students. But if you see about the impact very last, I think last backs, I had given a talk in NIT Patna also, and there also had given a talk on impact only, because the impact nowadays, I'm feeling the impact nowadays, it has a lot of potential to improve the mechanical, to improve this type of the materials in the new design. See, if you see about this type of the material impact strength, if you improve, you can say about the sellability of the market is become very high without increase the weight of the material, if we can increase the strength of the materials. So there is some design behind that, there is some mathematics behind that, there is some good pointage behind that we are going to discuss in coming slides. Okay, without increasing the weight, we can improve the strength of the materials, and this is the beauty of the research. Okay, so if you can say about a sudden instantaneous impulsive force on a limited area of composites laminate can be defined as an impact. Based on this, we can say about low velocity impact, high velocity impact, and hyper velocity impact. Okay, a variety of the failure modes can occur on impact damage. Impact energy is dissipated in forms of the deformation, delamination, stuck of impactor inside impacted body on the complete penetration. Here I am going a little slow, and I tell you, when it is impacted. See, as a mechanical engineer, if I hope you are able to see my hands. If I can say this is my hands, and I can say you please bring a pencil, and you are putting it here. Sometimes you feel that yes, your pencil, you feel very bad. Arey pencil mere haath mein chala jayega. Or if you see the needles of that, what will happen? It will inject it, and blood is coming out. For a mechanical engineer, what is the reason for that? In the mechanical language, how we can define it? We can say that at that point of time, stress concentration is very high, so this injection is going inside my hands. Mechanical language, stress concentration is very high at that point. So if I can control the stress concentration, if I can minimize the stress concentration, if I can strengthen the materials, so what will happen? it will not allow to injection to go inside your hands. Okay, so see the vice versa. I have to make the injection very powerful, and I have to make the body very powerful. So injection should not go inside of that. See the beauty of the research. See the beauty of the research. If we can say about those type of the thought in terms of the impact energy, what will happen? It is going to the impacted. If I can say about see the once the flight is moving in the air. Okay, so lightning is takes place. If you have the information, otherwise I am going to share this information.
I think some network issue with Professor KK Singh sir. Just wait. A call. Hello, sir. Hello.
Sir, I think network problem, sir.
Yeah. KK Singh sir have some network
Yes.
problem. Yeah. Sir,
Yes,
we are
you-
audible, sir?
yes, yes,
Yeah.
yes.
Sir, but
हाँ, थोड़ा कट गया था, बस फिर मैं जोड़ देता हूँ.
okay, sir.
Are you able to see my screen now?
Not now, sir, but some blank screen is coming. Not,
Okay, एक
not
second, रुकिए, एक second. अब
yes, sir. Yes, sir.
screen is visible now?
Yeah. Yes, sir.
Yes. Okay, thank you. क्या कीजिएगा, अब इलेक्ट्रॉनिक्स जमाना है, थोड़ा ठग लेता है.
Yes, sir.
कोई बात नहीं, अगर नहीं भी नेट चलेगा तब भी हम बोल देंगे. कोई बात. Okay, so we are here and okay, we are here and we are talking about of the impactor, and we are talking about some of the materials behavior of that. So before going to this, in the impact area, we have the many type of the literature is available, but in all this literature, first of all, see if you are doing it is connected, no? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
connected.
okay. So if you see about the, if you are pursuing, doing your PhD, especially the PhD student, please don't always just refer the paper and see your research. Just see some of the basic book. Here I am talking about for this impact in the, we have one book is written by the Abrat. If you see this Abrat, we will find out this Abrat is nothing but the Bible in terms of the impact in the composite materials. If you read the every chapter, you will find out some of the new information for that. So my suggestion is here, when you are a PhD student, you are reviewing the paper, you are doing the literature survey, please also read some of the good books in your area, so you will get some of the basic information, and that will use in your research work. So now, for this, when we talk about the this impact study, we have to find out what are the research gap, so we can go ahead on that. Some of the PhD students working with you, you cannot say you go and work on this area, will get a fruitful results. So first of all, what you have to say, we have to say them, you just find out what other people have done, and where is the area where you can do something, and that area you can say the green area. Then only that student can start the work. Simply we cannot say the student here, please do it in that area, you will get some fruitful result, and that may not be useful. Okay, so whenever we'll talk about this type of the basic information from the some of the books, that is very useful for that. So here in this, for today talk, we'll talk about the research objective. Here we'll talk about impact tolerance of the fiber epoxy. Okay, then we'll talk about the enhanced damage tolerance of the FRPs beyond design limitation, and we are introducing one of the new things, that MWCNT, multi-wall carbon nanotubes, and its ranges from 0 to 4 weight percentage, and this research proposed an optimum design percentage for maximum damage resistance of Gfrp and CFRP. And then we'll talk about low velocity impact and validated by LS Dana. See, honestly speaking, this is the slide of the one of the PhD student. Currently, he is now, I told you, the faculty in IIT Madras. I have taken this slide in front of you. I will use very few slides from this. I want to give you some of the basic information that may be useful for your research. Just 15 years back, when we are impacted the material, it is very difficult to find out how much area is going to damage. And we are not aware about the LS Nano softwares. Okay, so that times we are impacted it and see about how much area is going to damage, and then we have to prepare the zinc iodide solution and put it inside to that, okay, by using some of the ordinary injection, and then we have to burn it. After burning it, what will happen? That damaged area, the color is going to change, yellowish color is coming, and then we have to take those areas, we'll find out how much this area is damaged in the every layers, and then we have to find out those damaged area, and we can say if this is going to the impacted by this much energy is going to the absorb, and this much area is going to the damaged. Okay, and this information I have presented in 2004, one of the international conference in ITBHU. Okay, and we got the best paper award. That you can see about the impact strength in what is in 2004. This type of the information we do not have from the softwares. Nowadays, if you want to impact it, before going to the lab, we can design the material, we can impact it by using the LS Dana, and we can say how much the damage takes place, and then we are impacted it, and finally see the correlation. What is in the softwares and what is coming in the experimental way, and you can make the comparison. See the quality of the research from last 15 years in today. See the quality of the research. See the next. Sometimes we will talk about I am working on the advanced composites. So what is meaning of your advanced? Please don't confuse. If some of the research paper will finding out advanced composites, that means fiber volume ratio is more than 50%. Then they are identified that and putting the name, it's nothing but the advanced composites or nothing more than that. And then we have to see about the one more things. Here I have the second line, you are just about see the MWCNT, multi-wall carbon nanotubes. This MWCNT also have the very different story in my lab. We are not purchasing it MWCNT from the market. We are making it by arcing methods. And one of the MTech student had worked 2 years, and we are able to finding out nothing. And finally, we have put it one of the PhD and group of BTech student. We are developing here in the department multi-wall carbon nanotubes, size is 24 nanometers. And it's not my information I'm giving you. It's the information we have collected it from the TM, transmission electron microscopy study we have done in the Tata Steel to pay them. And we got this information. The size of the MWCNT is 24 nanometer developed in our lab. So this MWCNT we are using to make the FRP composites as a MWCNT. We are mixing the different percentage with the reagents and making this to increase the strength for that. See the small things, how we are adding them, and see the quality of the research we are improving in terms of this area. Not in India, I can say the international markets. The composite part B is the Q1 papers. In the Q1 journals, the number is 1 composite part B. So we have published a paper in composite part B. That means our research quality, we are not comparing the Indian market, we are comparing international market in this field. So we are giving to the new information to the international community in the field of the impact and the design of the composites. So MWCNT also we can manufacture it, and also we can design the material in the lab, and we can impact it and test it and validate it by the LS Dano softwares. So these are the complete study is going on now the present in my group of the PhD students. So see now basic information. I have told you if the some of the student is very new, say they can get some information. So see this basic information. If you see about these materials, many of the times if you ask that, we have to design this material in terms of the different angle of configuration. So this is the angle of configuration, and here we can say about this this one more pattern we are using in our lab to make these composites. Now the question is here, थोड़ा सा inside subject के अंदर चलते हैं and see about why we are putting all this, why we are going for this 0, 90 and all this. What is happen when you are doing the mechanical testing for that? See the basic information for that. Again, we can say this the source I'm telling you, so you can study, and after the seminar also you can send me the mail. This information I am providing you from RM Jones Mechanics of Composite Materials. These books I am providing this information. So this is the orientation of the fibers in a layer, and N is the number of layers having the thickness. See this equation. Here A is the extension stiffness matrix, B bending extension coupling stiffness matrix, and D is the bending stiffness matrix. And see this is the classic laminate theory. In this classic laminate theory from RM Jones I am talking to you. If you are doing the research in this area, please you can open the book and you can see this equation. From there, this is the my input, and I have published in 2008. Okay, here on impact, delineation of crack can move in any direction from the impactor. Proposed laminate A, B, and D are determined for the transport. So orientation of the axis X dash, Y dash. This information I am telling you what we have done. So here, if you solve this equation, the defining the components of the bending extension coupling stiffness matrix, you can solve it. And you can find out, see this information, I just read this. The transform reduced stiffness matrix of kth ply, this number of plies there, one ply is the kth ply, you can say the middle of that. HK, the thickness of the kth ply from the mid plane. From the mid plane, what are the targeting ply? If you suppose this is the K ply, so the kth ply, the distance between from the mid plane to that ply. ZK, distance of the centroid of kth layer from the mid plane. From mid plane to that layer, what is the distance? And TK, thickness of the kth layer. What is the thickness of that? आपने वहाँ पे you have to put 00 or 90 or 45. Let's show you about the thickness of the layer and what is the GSM of that. 500 GSM or 200 GSM. That also showing the thickness of the materials. So if you solve it, finally solving it, we are getting it Bij is equal to 0. Once the Bij is equal to 0, we can say about this matrix is transferring completely the stresses from one point to the other points, and Bij equal to 0. Here one of the green area is again also there. Green area is again also there. There people is, we are taking a material and we are solving it and finding out Bij equal to 0 or not. Here we try to see what is happening in case of the symmetric and in case of the asymmetric. Look at this figure. Look at this figure. When we talk about the symmetric, you just see the upper part of that and lower part of that. It is nothing but the repeated ones. अगर आप क्लास में खड़े हैं, एक साइड में बेंच पे 4 बच्चे बैठे हैं, दूसरे साइड पर भी 4 बच्चे बैठे हैं. That means we can see it's nothing but the symmetric. Like that, you can see here phi n, theta 2 and theta 2 and phi n, phi n. Just you fold it, it is overlap. So we can say this is the case of the symmetric. If you can say about sometimes this is the case of the asymmetric, that means this type of the phenomena is not takes place. So in case of the symmetric, have its own beauty, and in case of asymmetric, have its again other beauty. Okay, so these both the properties of the material in case of the symmetric and asymmetric, based on the mechanical requirements, mechanical properties requirements. You need a material where you want a good toughness. You need a material where you want G1C should be good, or you want a material their mode 2 should be good, or you want a material their impact should be good, or you want a material their fatigue should be good. Which type of properties you want? Based on those study, you please select the materials Simply you cannot say we have a composite and we are working on the impact or working on the fatigue or working on the GNC or working on the G2C. Means mode 1 and mode 2. We have to see about, we have to calculate it, design the material and see what type of material is best suited for the different types of study, what exactly you have the required. Okay. So material fabrication, again I am showing you this figure from my lab. We have the matrix, epoxy and hardener, reinforcement, glass and carbon woven, FRP composites, and also we have this type of the constituents. We have to make it by using the hardener and accelerator. Okay. So if you see about the reinforcements, we can say about based on orientation of width and breadth of the fabrics and multi-wall carbon nanotubes as a secondary reinforcement. Abhi main aapko yahi bataya, just now I have told you. If you want to make it, you have to make it. If you want to purchase it, you can purchase it. It is available from the United Nanotech Innovations PBT Ltd, Bangalore. Okay. So if it is up to you. If you want to, so if I'm making it, I just giving the some of the basic information. We have made that materials by using the mechanical arcing methods. Ab kaise banaya? What is the procedure for that? That required a separate 1 hour. Okay. So that is 50% of a PhD students. It required 1 more lecture. So we are making those type of the MWCNT in the lab by using the arcing methods. And sometimes the student is not using those. Sometimes they can purchase it and also they can make the multi-wall carbon nanotubes. Use they are as a secondary reinforcement and make the composites. Nature of fabric. Bidirectional plain glass fiber woven fabrics. Okay. So here we are taking 0 and 90, and this is also purchased from the industries. Name is given here, MS Industries Kolkata, and also it is available in the industries in Delhi also. But finally, with the nearby, we are purchasing it this, and present work thermosetting epoxy. We are using the at the room temperature, and also we are using the hardener and accelerator. This is supplied by the ATAL Limited, the Balsad. Okay. Now coming to the laminate preparation. So mixing of MWCNT, we have to use of organic solvent followed by the high energy homogenization techniques. The process is started with the moisture removal from the procured MWCNT by drying it in a tray inside a closed oven at 600 degrees centigrade for 24 hours. Before mixing multi-wall MWCNT in the reagents, surface modification of procured nanotubes were done using hydrogen peroxide 20%. 10 grams of MWCNT was mixed with 150 ml ethanol, and sonication process was carried out for 10 minutes of an interval of 10 minutes. It is done in such a manner to avoid damaging of the graphene layers of multi-wall carbon nanotube surface. Okay, so these are the basic information how we are mixing it and mixing it with the multi-wall carbon nanotubes and with the reagents. So these are the information for that. I have told you all this without looking the slide. I have given all this information to you. So we have to now, once it is mixing it up, then you have to take layer by layer and you have to put the resin on the surface for that. And then you have to use the rollers and remove the extra resin. And after that, we have to put this complete in this manner. We have you can say this is the schematic diagram of the vacuum bagging setup. This setup is available with us. Okay, so this is the flat base. We have the laminate, and then we have the sealant here. That the release film is this, the bagging film is this, the breather is this, and the peel ply, the breather, the release film, and the vacuum house and vacuum bag. We have to pressurize it and let it be for the 24 hours, and then we have to remove it. So complete setup, we have to procure it here, and we are making the laminate in our lab itself from the basic fibers. You can see this diagram from the tabletop machine in the lab, and I can say this is completely designed by our group of students in the departments. Okay, so now once we are making this by these methods, and how can we say the material we have made it, this material is good or bad? We cannot say this material, anybody can procure this material. So and you can say what is the power volume of ratio for that. So we have make that testing for that, finding the volume fraction of that, and put it the small pieces of this composite in the furnace, see the initial weight, and you have to burn it, see the final weight, and you can find out the fiber volume fraction of the materials in the lab itself. And then after making this, sometimes also we have designed this. Here one more machine is there. Here it is not showing. One pressing machine we have designed. One pressing machine we have designed and developed by one of the private company near to the Delhi. Those machine also with us. There we have the heater and there we have the pressure. So there also sometimes we are making these materials by hand lab techniques, and without this vacuum bagging setups, we have to take these complete materials by using the hand lab techniques and put it in that pressing machine, and then see the area of that. And we have that top plate and bottom plate of that machine, finding out that area and then apply the pressure on that, how much pressure you want on that, so that you can see distally on the machine. And there you have to just show this pressure and temperature, let it be for few hours, and then just switch off that machine for the temperature, and then after one day just switch off the machine for the pressure. You can get a better laminate, good designs and good fiber volume ratio, and any types of the voids free surface you can get it. So these two technique we are using it in the lab and making the composites. So mechanical properties of the prepared laminate. So this available with us, the hospital. This is the 50 kilonewton. This machine is working condition in the lab, and we are using these machines also. So this machine we can use it for the 3-point bend test, or we can use it for the mode 1 testings. Mode 1 testing or mode 2 testing, we can use this machine in the lab, and this is in the working condition. The standard 0.1 to 10 mm per minute, loading type axial loading, and operating temperature up to minus 38 degrees. This is all this, but we are never tried. We are working on room temperatures. Always you should give the correct information to the research community. If I do mistakes, someone can correct me, but always you should give the correct information to the research community. Okay. So now the load versus displacement curve for the multi-wall carbon nanotubes of Gfrp. Gfrp means glass fiber reinforced polymer composites. We can say about is nothing but the flexural loadings. See here 1% of MWCNT mixed glass fiber, 2 weight percentage, 3 weight percentage, 4 weight percentage. See about how the loading is takes place and what is the failures. See the beauty of the failures. अब थोड़ा सा लेके आपको फंडामेंटल में चलते हैं, because most of the student is here. When we talk about material is loaded and it is going to follow the Hooke's law, then the lower yielding point, upper yielding point, ultimate point, and fracture point. You have attended the second year classes, and there you have to find out, yes, material is mild steel pieces and it is going to the fail by cup and cone arrangement. My dear student, have you asked your teachers, why it is cup and cone? Why it is cup and cone? If you have asked it, that's good. If you not, please ask him. Okay, and you will find all this solution. Please refer one book, Mechanical Metallurgy by George Dieter. Okay, there will get all this fundamental information, and you can enjoy with your mechanical testing of material study as a mechanical engineer. So if you see about those type of the things, mainly where the most of the phenomena is changing, material properties. If you see very carefully, from the upper yielding to the lower yielding, the material behavior, lot of properties is going to change. If you see about upper yielding to the lower yielding material behavior, every phenomena, there is you will get lot of information. But now, what is the case of the composites? What is the case of the composites? Here, once you are loading it, what will happen? Once you are loading it, it will reach some of the loads, and then finally, first layer is going to break it. It is coming out. It is coming down. Then second layer is taking the load. Again, it will take some load. Again, it is coming down, and material is just fill, and third layer is coming out. Suppose the 8th layer is there. 8 times the material is going to the fail, and material is again taking the loads. So this is the beauty of the composites. Whenever you are using those types of materials, we cannot say this is the whole phenomena is takes place between the upper yielding and the lower yielding and material is fail. Okay, so there you can see lot of information and finding out some different studies. Here, every layer of the materials, you will find out the material is able to take a load, even though it is failure. Some of the second layer of the material, it is able to take the load, and finally, material is going to the fail, when all the layers is going to the fail. And we are going to give the strength to the every layer of the materials, by increasing by mixing the MWCNTs. So we are giving the strength to the materials by mixing the MWCNT. So this is the beauty here for the mechanical testing of the composites. See here, see the both the things now in front of you. The MWCNT percentage and flexural strength. The neat one is 1%, 2%, 3%, and 4%. And see here, see the strength. See the flexural strength at the 3 weight percentage, it is 230. Again, 4 weight percentage, again is 190. If you see about, again, one more research is start from this point. It takes 15-20 minutes. Why it is going from the 3 weight percentage to 4 weight percentage, it is going down. Okay, so see if you talk about the multi-wall carbon nanotubes, you cannot say you have to take some percentage of that and mix it up and you can improve the strength for that. You have to study about what is the percentage and what is happened with the MWCNT once you are mixing with the epoxy, and what is the nature of these materials after mixing the MWCNT. At what level? So those are the studies also associated with this type of the research phenomenon. Now you see about the load versus displacement graph for the multi-wall carbon tubes Gfrps short beam test. If you see the short beam test, see the percentage of 1%, 2%, 3%, and 4%. Always you will be finding out 3 weight percentage of MWCNT is giving the better results. Okay, so before going to the impact, before going to the fatigue, these are the things is very much necessary, because this information we require to do the simulation of this type of the study in the coming research. So now coming to the drop bed impact test. See this drop bed impact testing machine. This machine is not available in ISM. We are using this machine from IT Delhi or IC Bangalore. Okay, so here we are using this machine for the impact testing. Here the material is one impacted. The impactor is going back and it is just hold by the magnet. Otherwise, what will happen? It is going to happen to the repeated impact. And once the repeated impact is there, then we can say our study is not going to complete. So it should be one, it is impacted it will one after impacted, this is impactor will going up and it is hold by the other means in the apparatus. So it should not be do the repeated impact. Okay, so this type of the machine is available in the different IITs. I have told you about where it is available. And here we are. Hello. Okay, so here. Hello, are you able to hear me?
Yes, sir.
Yes, sir.
Yes. Thank you. So the low velocity impact tests are conducted on Inston. This machine, the testing specimen, we have to say as per the machine requirement, what is the size of that machine, the base. From as for that, I can say currently we are making 10 by 12. A cylindrical steel impactor with the hemispherical head of the mass 10 kg was used here in this study, and hemispherical headed by the cylindrical impactor 12.7 mm diameter is used. So testing specimen are placed in between the movable and the fixed jaw and the constant in the transverse and the rotating directions. Okay, so now look at this this figure. There, this is showing just where it is exactly happening. So we have to press it and we have to see about how it is impacted. So here, if you see about this small video here, also you can see this slide how it is going to the impacted in the chambers. So now testing of the Gfrps. So the testing of multi-wall carbon nanotube Gfrp laminate impacted 3.5, 4.5, and 5.5 also. So we can say about this type of the testing, we can do it for the different weight percentage, maybe the 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and up to 5. So this in this group of the this student, we have taken this combination. But we have the data from the 0 to up to the 5 weight percentage of that. And then I have told you 3 weight percentage is very crucial. After that, some of the properties may not increase. Okay. So see this is the glass fiber. In this glass fiber, we can say about the glass fiber. We can also make this material in the lab. This material is procured in my lab itself, and there we can see the result for that. So now once it is impacted, it maybe the glass fiber, maybe the carbon fibers, and after impacted these materials, we have to see about how much energy is absorption. Energy is absorption with the different weight percentage of that. Again, you see the energy versus deformation at 4.5 meter per second. Then also you can see about 5.5 meter per second energy versus deformations. So see, look at it about in the different weight percentage, what is the nature of the graph. You can see it and you can find out what is happening with that. So energy absorption capacity of Gfrp, pure and modified, it was figure 13 AC at a velocity of 3.5 meter per second. So maximum damage caused at 3.5 meter per second indent velocity. Corresponding to this velocity, absorbed energy of the proposed sample were absorbed from 40 to 41.9 joules. Okay. So like that, we have tested it in the different weight percentage of that, and different weight percentage we have to test it. Then we have to see the load versus time displacement graph for the both the carbon fiber and for the glass fibers. And then we have to see about what is happening when we talk about this type of the multiple carbon nanotubes. What is happening with the resins, how it is going to the mix, how the crack is inserted. I have told you just now, you have the 8 layers of the material. You can see about 8 times it is going to take the load and fail it. You see here first crack, see the arrow of that, how the first crack is initiated. Okay, this is the enlarged diagram of the basic model. So here you can see about the different types of the crack, how it is initiated. See here, there is a lot of information is available here. We can say about the material is going to the impacted it at the different impactor at the different velocity, and we have the materials at the sum of the percentage value of optimum percentage value. We can say that is the better one. Now the damage we have to calculate it. See the laboratory level how we can calculate it, and I will show you also how it is calculated by using the software.
To analyze on the separation of power. So do we have to, it should be handwritten or typed?
Hello. Anybody have any doubts? Anybody want to ask me something? Hello.
Sir, no one can ask.
अच्छा, अगर कोई किसी को डाउट है तो आप पूछ सकते हैं, आप रोक सकते हैं. I won't feel bad. टीचर हैं, आप कभी भी रोक सकते हैं, ठीक है? So we have to see about damage area comparison. So 3.5 meter per second, 4.5 meter per second, 5.5 meter per second, and see the dropping weight velocity of the impactor: 0.5, 1, 1.5, 2, 2.5, 3, and 4. So see what is happening with that. This is the different weight percentage, and see the different materials, the impact energy and the area damage takes place at the different velocities. So this is the SM scanning. This machine also we don't have. This is we have tested it in ISC Bangalore. Okay. So this KSI scanning acoustics B series microscope is used to scan the 4 mm thickness. So we can find out very just beginning of this lecture. I have told you how we have tested it in 2004. Okay, zinc iodide solution. We have to put it inside and burn it and see the damage area. And now see the machine is available in front of you. Okay, so now we can see the damage area by the different types of the machine, different types of the technique, and see the quality of the research is improved from last 15 years. So this the area we can see it after impact and scan it and finding out how much area is going to impact. So validation of impact testing of Gfrp. Gfrp means glass fiber reinforced polymer composites. So this is the drop bit over a neat glass epoxy of 3.5, 4.5, and 5.5. Okay, and these are the model assumptions for that. So we can go inside. These are the information. Suppose when you are working on the LS data, you need some basic information. So you have to do the some of the testing in the mode 1 and mode 2 test. some of the information we required for doing the impact study on the LS data. So this information we got it from the mode 1 and mode 2 information, and then we have to put it all this for this LS data, this input, this especially this information: Young's modulus, Poisson's ratio, tensile strength, compressive strength, and shear strength. Okay, so whenever see this correct information, just I want to share with you. Once some of the student is changing the laminate, what is my first duty? First duty is to please find out all this information. If you are not changing the laminate, then we don't have any problem. You take the laminate, use this data and simulate and see. But once you are changing the laminate design, that means once you have the 090, once you have the 045 or the 050, if you want to change it, you first find out the BIJ and then find out this complete information by using the UTMSA. And then you can go for the simulation in LS-DANA. Otherwise, you cannot do it. They will ask you about the Young's modulus, Poisson's ratio, tensile strength. So this information is necessary for doing those type of the testings. See, once it is tested it, how it is, see the both the graphs. Once it is impacted it by using the LS-DANA, and other one is impacted it by in the lab. And we have to see the cross-section analysis of these both the things. The T is 1 meter per second, see 4.5, 3.5, and 5.5. How it is, cross-section view of the glass epoxy laminate in time steps. A 3.5, B 4.5, and C 5.5. See, this is going to happen in case of the in the simulation process. We can see it. Comparison table for the energy absorption. See this experimental value 41.3. See the simulation value 43.5. What is variation? 5%. That means we can say our experimental work was equally good compared to the simulation work, because 10% is acceptable. Now it is coming 5%, 0.75, 2.7%, and 2.3%. So what we are doing, the level of the experimental work in the lab, making the materials, design and simulate those things, that research quality is showing the difference here in the variation. It is 5 or less than 5. So this is showing the good quality of the research. Now the damage area in FEM analysis, we can use this, and we can see these materials in our machines. So there we have to also we have facility the SEM facility, scanning electron microscopy. There you can see the damage and the fiber volume breakage for that. So testing of CFRP, carbon fiber reinforced polymers. Here, droplet impact testing of the carbon organ epoxy composite reinforced with multi-wall carbon nanotubes in a doping range 0 to 4 bit percentage of resin were tested in order to find an optimum MWCNT loading percentage. 5 set of samples at 0% near CFRP as reference, 1%, 1 weight percentage, 2 weight percentage, 3 weight percentage, and 4 weight percentage MWCNT percentage with 5 specimens, each are prepared as a ASTM D7136. See now, earlier it was showing the glass fiber, now I am showing for the carbon fiber and how it is going to the affected this base material for that. So see here how it is energy versus deformation at 4.5 meter per second. See here 3.5, 4.5, and 5.5. You will find out the basic difference in the carbon fiber and the glass fiber. So carbon fiber, because the carbon fiber is more stronger compared to glass fiber. So here this data is putting it here. This data reading of this data is no use. I can say only. So this is going to the carbon fiber. It is going to the giving to the more maximum energy variation compared to the glass fiber in case of the carbon fibers. So see the load versus time curve. I have told you the initial in case of the carbon fiber. See here, once it is cracked it, first crack, what is going to happen? Then second crack, third crack, fourth crack. See here, once crack is there, again it is taking the load. Crack is there, again it is taking the load. Finally, once it is going to the fail, and finally it is fail. Okay, so here see the beauty of that. See the beauty of the mild steel and here in the composites, especially when the composite is composite associated with the multi-wall carbon nanotubes. When you are putting the multi-wall carbon nanotubes with the composites, see the strength of these materials. Again, also the force time response at the V4 point velocity 4.5 meter per second, again 5.5 meter per second. Okay, so load time curve expresses the maximum load carrying capacity of the specimen. First crack initiate. Now it is again also the very interesting things. मैं यहाँ थोड़ा सा रुकता हूँ. Whenever we'll talk about the materials is going to the fail. Now you have to just thought about that. Yes, material is going to the fail. How the crack is propagated? Once we'll talk about crack propagated, first of all, we have to see about how the crack was initiated and what is the base material. In that base material, how the first crack is going to the initiate. How it is going to the initiate? A fundamental question. How it is going to the initiate? It may be the material defects only. When material was procured in the laboratory itself, there is a defect in the material itself. That from that point only crack initiation will take place. Now I can say there is no defects in the material procurement. Where the defects will start and crack initiation will take place. Crack initiation will take place when you study the few hours long, or you playing the few hours long. What exactly you are doing in your house? You are coming back, you are asking your mom to give me a cup of coffee because you feel fatigue and you feel tired. Why you want a cup of coffee? Because you want to regain your energy. You want to regain your energy so you can study again 2 hours, or you can go for playing for the 2 hours outside from your home. So once you are asking for the coffee, that means that time for your body, for me as a biomaterial, they need energy. They need energy, and you are asking a cup of coffee or a cup of Horlicks or Complan. So when we talk about those type of the drink energy for the giving the input to your body, for me as a biomaterial. Like that, this type of the material is also required some of the internal energy, internal booster. If it is available, sometimes of this material, it is not going to the fail. And for my material, I can say the coffee or Complan or the Horlicks is nothing but here MWCNT. We are putting the MWCNT here, so that is going to the resist. They are not going to the fail immediately. They require some more times. That means they need some more load. They are going to sustain some more energy before going to the fail. So without using the additional load on the surface of the materials or the weight of the materials, we are going to increase the strength of the materials, and answer is this type of the research. We can use this multi-wall carbon nanotubes like your mom is giving a cup of coffee to you. Okay, so this type of research we are adding it and giving the better properties of the material. So for if you see about this type of the research have the different, but finally the material is going to the fail. Maybe the glass fiber, maybe the carbon fibers. What is the basic difference? Carbon fibers is going to fail, require the more strength. See, if you for your body, if it is the biomaterial, for me, some people is always sick. Some people is very strong. That means for them biomaterial, for me it is a very strong material. So it is very few times it is going to the sick. Okay. So here also you see the carbon fibers, it is going to the fail when it is the high impactors. Otherwise, it is not going to the fail. So damage area comparison, see the basic information for the research, 3.5, 4.5 and 5.5. So this 1 weight percentage of this multi-wall carbon nanotubes, see in the 3.5, 4.5 and 5.5, what is going to the happen? Okay, velocity of the impact. I see that clearly the result is in front of you. Okay, so this is the, I have told you the previous in glass fibers, we have to done the carbon fiber for the scanning, and we have to see this information from this machine, how much it is going to the damage, how much it is going to the damage. Okay, so now you can see about the failure analysis of this. So this failure analysis of this by using some of the spectrography. So this also you can see it by using it, some of the information I have told you. We have taken it this on the scanning electron microscope SEM study, and these are the graphs showing from the scanning electron microscopy. So dispersion state of MWCNT bulk materials. Okay, A is 1.5 weight percentage, 2 is, B is 2 weight percentage, 3 is 3.0 weight percentage, and 4 is, D is 4.0 weight percentage respectively. So see this graph and you can find out where it is showing and what are the properties based on this mixing of that. Now the see the nanotubes of that. See here again, we have put one additional information in the nanos. Some of the nanotubes it look like a onion. Some of the nanotubes it look like a flowers, flowers. So we have taken this type of information, and one of the PhD students from BIT Sindri, Professor Sunil Chaudhary, was with me. So we have taken this type of the information and studied, and we have published some good papers based on the manufacturing of this multi-wall carbon nanotubes in terms of the onion or in terms of the cauliflower it look like, and showing the strength of these materials. Okay, so some good papers which also came out only from the multi-wall carbon nanotubes. So we can say this type of the research we have to take it, and this is application for that. In this research we have application of this multi-wall carbon nanotubes. See this figure, see the figure A, B, C, and D. Dispersion state of MWC in the bulk materials, 1 weight percentage, A, B 2 weight percentage, C 3 weight percentage, and D 4%. See the size of that. See the direction. I want to just share one more information. Now people is talking about, we have put it the multi-wall carbon nanotubes. People is talking about in the casting. Have you heard about in the casting directional solidifications? Yes, definitely. You have studied in the casting subject in mechanical engineer. I hope you know about the directional certification. So in such type of the research process also, if I can say the directional distribution of the multi-wall carbon nanotubes inside the composites is also become the very good research area. Very good research area. We have to see what is going to happen. We now in this process. Okay. So now look at it about this different types of the process, how multi-wall carbon nanotubes it is going to the placed in just the accumularization may takes place, and it is going to the not very good behavior once this is takes place. When this is distributed uniformly, then this is showing the very good behavior. So that means we have to mix it. We have to mix it, and after mixing it, we have to say about. After mixing it, we have to say about mixing method is good or not. We are doing the mixing at ultrasonically. Ultrasonic mixing method we are using it. Okay, so this is the field emission, the FESM diagrams for that, for multi-wall carbon nanotubes distribution, and see this all this alchemization is takes place here in the other figures. Look at my cursor here in the both the sides. So this is the outcome for that. Yes, I can say the here without looking also I can tell you this here I can say the materials in the carbon fiber it is more tougher, stronger compared to the glass fiber by using the MWCNT also. The flexure strength is improved by 71%, weight percentage of 3 weight percentage of MWCNT compared to the glass fibers. Again also the 49% of energy absorption is improved in the 5.5 meter per second as compared to the neat Gfrps. Means that we are always here. This is the information I am giving you. Two types of information. One information is between glass and carbon. Other information I am giving you glass itself or carbon itself in the different weight of percentage of mixing. 1%, 2%, 3%, 4%, 5 weight percentage. So these two types of the information I am giving it here by using the compared to the two different materials, or maybe the one material in the different weight percentage, and these are the references coming under only in the impact area for that. Okay, so I can say this is the PPT presentation is ending here. I just want to give you some more information without showing any type of the slides. Okay, just okay. So here the purpose of this showing this slide and giving this information. Whenever we'll talk about the mild steel or in the cast iron, we are preparing in the lab, and we can make it showing the different of the mechanical behavior to showing to the strength. So these type of the materials, once you can prepare it or we can use it, you can now see your surroundings. You can now see your surroundings. See your where in the building construction, see the windows, see the automobiles, see the aerospace industries, and there if you can use some of the additional this information. Some of the people is also using more of the biomaterials. biomaterials is available in your surroundings, but we have to see about what is the strength for that. What is the strength for that? So you are getting a better strength. If you are getting a good mechanical properties for that, you can use those type of the materials in terms of the in the mechanical industries for making the different types of the product. My dear students, if you remember that basic fundamental repeating, once you are going for the cement tight region, you can increase some of the mechanical behavior, but some of the mechanical behavior is also going to decrease. So when you are opting as a fresh mechanical engineer, when you are going to the industries and you are making a product, and that time you have to see, you have the choice. If someone is asking you what type of material you are going to select it, you have to say something, no, which type of material, what are the mechanical properties you want. So those fundamental information should be with you. Otherwise, you cannot become a success mechanical engineer in the industries. Then later on, research will come and MTech and PhD will come. First, the basic mechanical engineering, we have to see about what are the basic mechanical properties we can add to the materials. Because suppose you take a very fundamental examples, If you are talking for the heat treatment, I can say the heat treatment is nothing but the adding some of the behavior and removing some of the behaviors. Whatever the properties, it is not you know about normalizing and know about the annulings, it's a heat treatment. As a mechanical engineer, what properties you want? Or adding those properties, you can add it by using the mechanical testing and by changing the some of the mechanical basic material that will become the added advantage in your CV. अगर आप as a mechanical engineer, if you know about fundamental of metallurgy, fundamental of new materials, how the new materials sit. Sometimes if when you are alone, just to sit and think about what is a material for the pen drive, what is a material for the disk, what is a material for this TV screen, okay, and see about, you will get a lot of information. And if you are sitting alone, you will think for that and you enjoy yourself. आपको भी feel नहीं होगा कि आप अकेले बैठे हुए हो. And find out what type of the things I can change it. अगर आपने उसका without changing, I have taken example for a copy example for you and given example just now. So that means we are giving some of the additional information to the material fields so we can get the new material. So our design should be good. And once the design should be good, we can give the new product in the market. Okay. So now I can say here, if anybody have any fundamentals doubts or anything want, they can ask me. Otherwise, whatever I had shown you, that manufacturing video also I have brought it that I want to show you. So can I show that video? Yes.
Yes, sir.
Yes. Okay. Are you able to see the screen?
Yes,
स्क्रीन
sir, yes.
दिखाई पड़ रहा है आपको?
Yes, sir. हाँ,
Yes, sir,
दिखाई
it's
दे रहा है.
visible, sir.
Yes, sir. Visual.
स्क्रीन दिखाई पड़ रहा है ना?
Yes, sir. Visual, sir.
ठीक, मैं ये इसको चलाता हूँ. इस वीडियो को आप देखिए और इसके साथ हम टाइम टू टाइम आपको बताते रहेंगे व्हाट इज हैपनिंग हियर. So this is the Department of Mechanical Engineering. Of that, and there is a one part of this we have to manufacture prepare the composite laminates. laminates, making these laminates, we have to first design the
इसके लिए व्हाट्सएप नंबर चाहिए
next is know that the nanocomposites it might be I have told you about this machine in my presentation. This machine was designed and developed by one of the private company. Here, this is the heater and also is the pressure. So heater and pressure both is available in this machine. This is Are you able to see this video, no?
Yes, sir.
Yes.
Yes. So here the Prashant is working now in IT Chennai, Sunil in BIT Sindri, Dheeraj in Australia, and Nandkishore in USA, Rowan University.
For this, we are using two helical plates rotating at the RPM of approximately 900. Next, the NTL is roughly for 5 to 10 minutes. For proper mixing of the PNT so that the aluminate part will change the operating format. So I can see in the
Hello, sir. If the sound is increasing, sir, better.
Yes.
Someone asking the
Take,
audio
take.
is not audible. If the
Now,
sound, yeah, little bit okay, sir.
thank you. A layer of the fibers. And then after that, again, you have to give the next layer of this CNT based epoxy on the first layer of these fibers. And it should be used the hand. This is the hand layer techniques. There we have to place it and extra resin will come out. But in this case, we have to place it by using the vacuum pressers. So once we are providing the vacuum pressers for this extra resin, it will suck and absorb, and it will give the pressure on the whole surface of this material. And finally, we are getting a better material compared to that is the extra advantage. We are getting this like this vacuum pressers. Now put it the next layer. Or you want to first put the rollers after this? Yes. Using the roller from pressure, that's why some extra applying pressure and quality on the layer, some extra resin. After we have chemical with having a pores. This is nothing but a perforated capacity. We have to make the hole here at the distance of the 1 centimeters approximately. And it is a perforated seal. We have to place it here. Once we have to put the perforated seal here, after that apply the pressure, what will happen? All the resins will come back to this pores will come up. Okay. So all the resin will suck up. The pressure is back on the surface. Extra resin will think that is not possible. This one,
called end of plate. So here purpose is to apply the uniform pressure on this laminate. We suck the air and apply the pressure on this. Now using this pump, we are getting this piping here, and we have create the pressure on the surface of this. So you say using this one to remove some pressure and once it rises into this vacuum pipe, when pressure applied on it, what happens? So marks on the material and you can use this one. We are getting the required pressure where you can see the dot, this dot signifying the extra epoxy which are coming out of the converted plus the extra layer from the side.
Trial version.
We are getting 1500 it's a very
Trial version.
next one the
Trial version.
this polymer composite. This much pressure half an hour sufficient. Good enough make this
Trial version.
give it 124 hours. And the next day after 24 hours
Trial version.
No audio.
specimen.
Okay.
From the and the final output is we have cutted this plates according to our desire by the cutter which this cutter has the blade of used for cutting of marbles. Then we have cutting this specimen and we are making the small specimen. So this is the final specimens what we are cutting using this cutters, and this we have prepared it for the impact testing areas. Likewise, we want to do the G1C, G2C, or any other types of the mechanical testing. We have to prepare the first we have to prepare the specimen. After that, as per about the ASTM to the requirement, we have to cut the specimens and cut the systems. So this is the non-speed machines available here. It is a completely calibrated machines, and we can cut the specimens after cutting the specimens immediately, and we can do the mechanical testings. If we want to do the load, these are two types of the machines we have. This is for the 50 kilometer species we have now available. And last I can say, thanks to my all the students, the group member of this research group, and finally Eddie, and we will test the. Thank you. And last I can say, thank you. Hello.
Yes, sir.
Yes,
Yes.
sir.
Yeah. So whatever I have told you in my lecture, I just try to show some of the video. It is prepared by the student only in the lab. So sometimes there is some problem in the audio. It was not prepared by the professional body. It was prepared by the student only. And this is the information I had today. I had shared with you. Now forum is open for discussion or any type of things. If anybody have any queries or any discussion, we can happily give.
Dear participants, if any query related to sir presentation, please ask.
Good afternoon, sir.
Good afternoon.
Sir, I am QD, sir.
So during the rolling, sir, some of the epoxy resin is removed from the laminated composite.
Yes.
So how can determine the survey percentage of the epoxy and fiber in a composite?
That I told you, once we have to make the composites, after that, when the procurement is over, before that we have to take the small pieces of that and put it in the furnace and heat it. And after heating it, what will happen? All the chemical will burn out, only fiber is there. So we have to see the initial weight, we have to see the final weight, and then we can find out the fiber volume percentage. But when you are making it, that time you cannot say what is the fiber volume percentage. So once you are making it, after that you can find out what is the fiber volume percentage. So during my lecture, one time I also talk about, some people will talk about, I'm working on advanced composites. So what is the meaning of the advanced composite? If the fiber volume is more than 50%. But that
So
is happening, we have to calculate it.
How much temperature, sir, is required for melting?
Here in this we are putting the temperature when you are pressing it in the pressing machine, and heater is with us. So there initially we are putting the temperature around 100 110. Okay, and then we have to constant this pressure for the 2 hours. Then the pressure is also constant. Then slowly we are shut down the heaters, and pressure is continue for the depends upon the weather. If it is a hot weather, we have to continue for 6 to 7 hours. If it is the cold weather, we have to sorry मैं थोड़ा उल्टा बोल दिया. If it is the cold weather, we have to put it 6 to 7 hours. If it is the hot weather, it will take some more times. So it may take one night also, 12 to 14 hours. You have to press it and leave it. When you're coming to the next day morning, you just remove that. You will find out the composite is ready. Then you have to take it and cut it as per your specimen requirement.
But sir, some students are working on the natural fibers reinforced composite, sir. So in that case, how can determine, because natural fiber is also burning in that condition?
What type of natural fibers they are working?
Suppose that's the jute fibers or banana fibers like this.
If it is the banana fibers, or if I can say the example for the jute also, there you have to see about what type of the fibers they are taking. They may be the unidirectional, or they may be the bidirectional. What type of fiber they are using?
Sir, bidirectional.
Bidirectional. If it is the bidirectional, what is the GSM for that?
GSMs are 400 approximately.
If it's GSM for 400, then you have to see about the thread. What is the diameter of the thread in the both the angles, in the 0 and 90 side?
Yes.
Then we have to calculate all this. Then we can say about this much pressure we should apply, or this much temperature for the apply for this is the biomaterials.
Okay, okay. Thank you so much, sir.
आपको एक लिमिट तक मतलब एक कंक्लूजन पहुंचने के पहले थोड़ा बहुत ट्रायल एरर चाहिए. So you make like that. You make a group of BTech, and there they will go for the trial and error. Then give the same work to the MTech, and slowly you will find out some of the stage there will get saturated. These are the value is required. I have told you in one place, when I shifting from the experimental work to the LS Dana, some of the basic properties required. If I am shifting the material direction, that means if I am using the 090, that means the tensile strength, the Poisson's ratio, all are the same. Now suppose some group of students, I am changing that. Because why? We found that in 2009, the symmetric case is better than the asymmetric in case of the impact. But sometimes it may not for the other mechanical properties. So once we are changing to the fiber configuration, from the 090 to other, means 045 or 015. So first of all, what we have to do? We have to find out the Bij. If Bij equal to 0, then we have to see about what are the different mechanical properties. For that, we have to use the UTM and see the different mechanical properties, because those mechanical properties is become the input properties of the software. Okay, so you have to make the 2-3 groups, one group for the basic research, one group for the advanced research. So that manner you can complete in 3-4 months one small research in that manner. Otherwise, one group will start from the scratch, it will take more time to complete it.
Okay, okay. Thank you so much, sir.
Thank you.
Anyone? Any query?
Yes. Hello, I'm Dr. Krishna Gowda.
Yes,
First of all, I would like to thank NIT Manipur for hosting such a nice faculty development program. program, and I will also like to thank Professor KK Singh for the nice presentation regarding this composite. From the I will say that for the basic students who will starting from composite also, he can understand lot many things the way sir presented. From my experience in the area of composite, I have few questions. If sir permits, then I will ask. Sir, may I have some questions?
Yeah, please.
Yeah, sir. What during that experimental work, I have observed that after mixing the filler material and the thermosetting polymer resin, whatever we are using, then we are going for the degassing, because whenever you are mixing those things, what happens? Air bubbles are getting entrapped.
Okay.
So then what happens? We go for the degassing process.
Okay.
Okay. After degassing the process, sometimes we are using the hardener or the accelerator, what we call.
Yes.
Then after adding that also, if you mix that properly or thoroughly, then also some air bubbles are getting entrapped.
Yes.
Yeah. Then what happens? But what happens again whenever you are going for the degasification process, then the mixture actually gets harder. The epoxy and the hardener becomes hard actually.
No. I should correct it that way. Please. Whenever we are mixing it earlier, see from the basic we have started. We started in the ITI Dhanbad. We do not have the composite lab. We have started giving the name of the composite and giving the composite as an elective subject here. Okay. So I'm just directly coming to your queries. Whenever that time we are mixing it like this by hand lab technique, and this type of the problem was there. And when this type of the problem was there, our fiber volume ratio was not increasing more than 30 to 35%. Honestly, research information, please share it very honestly. So it was 30 to 35% fiber volume ratio was coming. Then we are mixing it by through the ultrasonically mixing. We have the ultrasonic machine in the just next to my lab. There we are mixing it and bringing this material and putting on the laminate on that. And then we are giving this under the vacuum bagging. So lot of extra material it is also absorbed in the beader sheet. That beader sheet you can say it's not like a blanket, the blanket thin sheet. So that beader sheet it is going to the absorb some of the extra material. Then we are putting it in the machine. I have shown you one of the machine in my video. That machine is heater and pressure both is there. So once you are heating these materials, these resins, what will happen? If any types of the bubbles or anything is there, that will become completely vanished because you are heating those materials again on the heater. At the same time, it was also pressing it. If you see the heater and pressure graph, you can see from the, you see the x-axis and the y-axis. What will happen? You are applying the pressure on that and heater in pressure and the temperature also. So pressure it is starting from 0 to 2 bar. Temperature it is reaching from 50 degree. Then it will go for the, suppose the thickness of the material, it should require the 7 bar pressure. So we'll go for the 7 bar optimum pressure. There you reach the temperature 100. Let it be for 2 hours. Let it be for 2 hours. Then everything will become vanished. There is no bubbles, nothing will take place. And then what will happen? Slowly just switch off the heater. And then we have to let it be pressure for again 2-3 hours. This would it will be settled down. And then slowly just switch off the pressure in the after 4 hours. It will slowly cool down and it will come to the 0 and material is ready. How we can say? How we can say yes, we have changes the process, we have changes the quality. How we can say? We have to again find out the fiber volume ratio. If the volume fraction of this material is more than 50%, so we can say earlier problem was that it was eliminated. Okay, so based on those study, I can say now this type of material, I cannot say it is 100% free, but I can say almost free, because if it is not almost free, we cannot improve the fiber volume ratio, means volume fraction we cannot improve. Okay, so this is logic behind that.
Okay,
आपने देखा होगा initially, please, आपने देखा होगा initially we are mixing. What is the mixer initially mixing method we have started in the lab? We have one juicer machine in the house. From there, juicer machine, the top things we have to take it out in the lab and try to see it is mixing or not. It is start properly mixing. Okay, then we have to think about, yes, see the fiber volume percentage, and finally we have to reach up to ultrasonically mixing. And once ultrasonically mixing, we have to use it, and also pressure is there, the temperature pressure that machine have to purchase it. Then I can say the now fiber volume fraction is more than 50%. and we can say it is eliminated. We cannot say 100% still today also, but if the fiber volume percentage is more than 50%, see the other good quality research paper. Other good quality research paper, those published in the Q1 journals, Q1 category journals, or you see the publication, those are using by the Airbus or Boeing, because Airbus and Boeing, two is the top icon in terms of the composite, is a flight company.
Yeah.
So there you see the what is the fiber volume fraction. They all are talking about more than 50%. So if I can produce the more than 50%, that means the direction of the research is good.
Yes, exactly.
This is the way we are doing.
Okay, sir. One more question that I have a practical experience.
And एक minute, Mr. What's your name? Kursna
Gouda.
Gouda. So I have just. Are you happy with my answer or not? Then next question.
Yes, sir. I am happy
Are you
that
satisfied?
that is one way that we can follow also, sir. And
Yes,
one
that
more
we are doing
practical
here.
Yes.
Yeah,
Okay,
that
sir.
we are doing in the lab.
Yes, sir.
Are you
One
from
more.
Karnataka?
No, sir. No, sir. I am from Odisha.
Where are you from?
Odisha.
Odisha. Yes, that way we are doing it in the lab. Next question,
That is,
please.
yes, sir. One more that one practical experience. What I will say, whenever we are purchasing this hardener and or the epoxy resin, then what
Okay.
happens? We are purchasing in a small quantity.
No, small quantity. We are purchasing it 20 liters, 50 liters.
Okay, that is okay, fine, sir. But if you are
Yeah.
purchasing in a small amount, like suppose of 5 kg or 5 liter or 10 liters, then at that time they are properly the vendors those who are supplying, they are not mentioning the expiry date and all those things. Mostly what I experienced.
No. We are purchasing the 20 liters, 50 liters. They are putting everything. We are purchasing it from the very good quality.
Okay. So might be sometimes the escalator and the epoxy gets hardened, and might be I think that might be the product.
No, nothing. No, not happening. No, not happening. I'm really stopping you. That is not happening in our case, because I'm using this not here started. During my as a SRF in IIC Bangalore, I have learned all this technique in IIC Bangalore, and when I joined this institute, I started from there, and I can say this many students had completed his work. We are not this type of problem will face where when we are adding some of the, if I'm not in the presence or some of the BTech student is there, they are not taking seriously. If I am there and BTech student is also very serious, because once they are, suppose now a group of BTech students is working with me in this project, and they given the campus in placement in the Morti, they ask a lot of questions from the composite, and I can say you all three are selected.
No, that
So
is
nowadays
nice.
BTech student is also working, and we are never finding such type of problem.
Okay, sir. Okay. Fine, sir. Hope to meet you if sometimes I get an opportunity.
Yes, thank you. Always welcome.
Okay, sir. Thank you. I will.
Any question, anyone?
Good morning, sir.
Good morning.
Sir, myself Santosh Kumar Yadav, research scholar from NIT Patna. Sir, my one doubt is, sir, when we mix a CNT powder in composite,
Yes.
at different weight percentage, 0.5 weight percentage, 1.5,
Yes.
2 percentage. So my question is, at which percentage the maximum strength of the composite will be attained, and it will be best for a machining process, such as if you want to ECDM process, then what percentage of CNT we should mix in the composite?
आप NIT पटना में किनके साथ काम कर रहे हैं? अभिषेक जी के साथ?
Yes, sir. Yes, sir.
Acha. So Abhishek is also very good friends for mine. So what will happen here when we are making this? One of my students is Dheeraj. He has done the work in that way, and currently one more student is with me, Raju. He is also work on the machining. When we have make a saturated 3 weight percentage is the best.
Yes.
By using a different technique, and also I had shown you some of the example. We are reach 3 weight percentage is the best. If you go more than 3, then some of the defects will start. So 3 weight percentage is the best. There we are using the multi-wall carbon nanotube mixing with the epoxy.
Okay, sir. Thank you, sir. Thank you.
Okay.
Sir.
You can refer some of the papers, or you can ask me some of the papers in my mail. I will send you that.
Okay. Thank you so much, sir.
Okay. Thank you, Santosh.
Okay. So anyone, because time is going on, so second session will is after 12, so time is over. So sir, we can bind, sir.
Yes, we can bind up. Before binding, again, I am just giving this information. Please
Yes,
encourage your friends or the students who have the MTech degree and some experience in agencies. Day after tomorrow, I need 2 project fellow for my project, and will pay them around 28,000 rupees per month for 2 years. Okay, so please advertise, see the IIT ISM website. Tomorrow or maybe today evening, I will give this information on the website, so that anyone may interested, they can apply for that. Okay. So thank you from my side.
Okay, sir. So thank you very much, sir. Abhishek.
Thank you, sir,
Yeah.
for taking out time from your very busy schedule to provide us with valuable information and like give the information about the approach for the research field, how to approach. And on behalf of all the coordinators, myself, and all the participants, I would take this time to thank you for the lecture, sir. Thank you, sir.
Thank you very much. Thank you all of you, and have a nice day.
So, dear participant, after KK Singh sir, the second session from Dr. Abhishek Singh sir will join soon. So, just wait for.
Hello. Dr. Saben, good afternoon.
Oh, Dr. Abhishek Singh already joined us. So, dear participant, so Dr. Abhishek Singh is join us. So, I am good afternoon, sir, and I am warm welcome to Dr. Abhishek Singh, sir. He is Dr. Abhishek Singh is my PhD guide, and I am the student of Dr. Abhishek Singh, and I am learned very much things from the Dr. Abhishek Singh, and I am requested to Dr. Abhishek to brief introduction about Dr. Abhishek Singh, sir. Abhishek.
Yes, sir. Good afternoon, sir. Yes, sir. Dr. Abhishek Singh was awarded with a PhD in Mechanical Engineering in 2014 by Indian Institute of Technology, Roorkee in year 2014. He joined National Institute of Technology, Patna in 2013 in the capacity of assistant professor and is presently having an experience over 8 years in teaching and research. He is the member of various national and international professional scientist societies such as MRSI, PAI, PMAI, ISME, IAENG, ASR, ISTE, etc. Dr. Abhishek Singh research areas are advanced and hybrid machine processing, machine of advanced materials, processing and characterization of composite materials, metal matrix composite, and biomaterials. In this journey, he has authored and published more than 60 research papers in various reputed national and international journals and 8 book chapters. Dr. Singh has also participated in over 44 national and international conferences of engineering held in India and overseas. He has traveled to the countries like Singapore, Japan, and Malaysia to present papers on various topics of manufacturing science. He has received 6 Best Research Paper Awards, 2 for his quality research. He has supervised 3 PhD theses and 6 PhD theses are in progress, 16 MTech dissertation and more than 20 BTech projects. He has also been invited to the scientific events in the India and abroad as the invited guest speaker and technical committee member. In addition to that, he has also been serving NIT Patna in the capacity of Nodal Officer, Department Academic Monitoring Coordinator, and as a member of various administrative committee of the institute. Thank you, sir. Thank you for having you for here.
Thank you, Abhishek, such for the nice introduction, and good afternoon to all of you. Before starting, first of all, I would like to thank all the participants that will have joined this 5-day AICT ATAL program, because any program is incomplete without the participants. Okay, so I would like to very thankful to all the participants, and I want to special thanks to the organizing team, Mr. Abhishek, and our team. You give me chance, and Dr. Sabendra has given me chance take a lecture in this ATAL FDP. Okay, and I want to another congratulations. Want to congratulate to Dr. Sabendra Kachap that he got a sponsored by the AICT ATAL. Okay, in this and in future I wish and pray to that we all meet again in physical mode in NIT Manipur, and we will work more together. Okay, okay, Abhishek.
Yes, sir. Thank you, sir.
Dr. Sabin, can I share my PPT?
Yes, sir.
Okay, thank you, thank you. Now my PPT is visible.
Yes, sir. It's visible, sir.
Okay. Okay, good afternoon to all of you. In my first slide, and my topic is based on the green composites. Okay, and Dr. Sabin,
Yes,
I
sir.
request before we start my PPT.
Yes, sir.
Actually, I have a go-to meeting. Okay, after
Yes, sir.
1 hour or 1.5 hours, so I will try to complete my PPT and lecture in timely manner. Okay.
Okay, sir.
And my PhD student also involved this PPT and part of this research in this lecture, who is working in this area and develop and characterize the composite material, Mr. Dr. Nitish Kumar. Okay. And I request to all the participants, if there any query and any questions from based of this green composite, you can ask directly my mail ID and you can directly ask to Dr. Nitish. Okay.
Okay, sir. Okay, sir. I'll convey the message.
Okay. Okay. Uh, Now, first, the introduction of the composite material. Everybody knows the composite materials, but composite material is made by the combination of two and more than two materials to the unique combination of the properties, and the final properties of the composite materials are better than the constituent material properties. Okay, the now days numerous environment problems are created by the several non-biodegradable materials in the world. Okay, the many researcher and scientists has been tried to develop materials which are the sustainable, having a no harmful effect on the environment, and are biodegradable and eco-friendly, such as a natural fiber composite, polymer composites. Okay, the many development of biodegradable composite materials are being used in automobile industries, and primarily for the auto parts such as a door panel, seat backs, and truck linear, etc. The composite materials is a which type of puzzle is the least two components which are the joint microscopy and are insoluble in other matrix or reinforcement. The name of the first constituent of the reinforcement and other constituent are the matrix. The continuous phase is called the matrix, and the fiber distributed over the matrix is called the reinforcement. The reinforcement phase can be present in many forms like fiber, grain, flax, etc. Some of the most remarkable achievement in the materials history are the achievement of the composite material, their design and technology to the manufacture them. Okay, these composite can be the transmute the low cost and the light weight of compared to the glass, carbon fiber, and such as jute, flax, hemp, banana, okay, etc. The composite material is formed by the reinforcing fibers in a matrix resin. Okay, the natural fiber used in green industries focused in agriculture, since they have a enormous potential. The common view of, however, that is the benefit of the natural fiber is lightweight, accessibility, and reusability, easy availability, heat. Okay, the development of new fiber new fiber composite consume a average 60% energy of the compared to the synthetic fiber composite like glass and carbon fiber composite. Okay, The backgrounds of composite materials. In word composite materials was first used internationally in 1950, and it was used in daily life in houses around a 1960. Okay, a composite is a multi-phase hybrid materials prepared with at least two components having different properties and shapes. By compounding the processes, the components retain their original properties in composite materials and also so as the additional characteristics that do not present in the any original component. Rapid achievement in the manufacturing sector has created the need of the materials to the develop in terms of the ability, density, rigidity, cost efficiency, and the most sustainability. Okay, the composite material has appear to the possess properties that represent their purpose of the various applications, the utilization of the natural and the synthetic fiber for the manufacturing of the composite material make it is useful for the various application diversion fields including construction, automobile, mechanical, aerospace, mining, and the biomedical, etc. In the past 20 years, researchers and scientists have presented the composite material choose a place of traditional material since a structural, uh, tribological, and mechanical behavior of the fiber reinforced composite material is short form of the FRC, fiber reinforced composite material. Okay, it significantly enhanced in daily lives while the use of the composite material increase day by day in the real life, making a materials long lasting and durable, and the replacing most the plastic and man fiber composite. Okay, development and processing of the natural fiber composite is also easier as compared to the plastic materials. Okay, next the uh, classification of composite material. First is the metal matrix composite. The composite materials, it's metal matrix composite. Metal matrix composite materials is contains not less than two components, one of the which is obviously metals, and the other one may or not be metallic substance. Okay, for example, types of metallic are aluminum, magnesium, titanium, and these composites. Okay, the metals are mainly for the strengthening in the order of improving their properties to fit and design requirements. Okay, here the improvement of in the properties means some properties may increase and some may be decrease. For instance, the elastic deformation and strength of the metals can be acoustic by the adding fibers and such as a silicon carbide, boron carbide, okay, which will be make it the resistance, thermal expansions, and also that the sometime makes the less electrical and thermal conductivity. The MMC have many benefits such as a high elastic workability at elevated temperature, no effect of the moistures, good fatigue strength, and better wear resistance over the monolithic metals like aluminum and also over the polymer matrix composite. When the metal are reinforced with the fiber, their ductility and the strength of the fracture decreases as compared to polymer matrix composite. Metal matrix composite are costlier, okay, and their manufacturing techniques are also not easy. In my PhD, we have developed in MMC in IIT Roorkee lab. Okay, this work and fabrication done by Dr. Nitish Kumar is developed in natural fiber-based composite material. Next is composite is polymer matrix composite. The polymer matrix composite contains different types of continuous or short fiber likes together using a matrix and original polymer. The aim of the polymer matrix composite is transfer load between the matrix to fibers. Okay, the main advantage of the polymer matrix composite are their lightweight, light stiffness, and light load capacity in the direction of their reinforcement. The polymer storage matrix composite in the polymer do not require high temperature and high pressure. A simple equipment is required for the production of the polymer matrix composite. That's why the composite for the polymer matrix quickly evolved, and the soon again gain prop- popularity in the structure application. Okay, the last one is ceramic matrix composite. Ceramic matrix composite are the types of composite subgroup as well as the ceramics subgroup, which are made of the ceramic fiber distributed over the continuous face of the ceramic matrix like carbon, silicon carbide, etc. The high strength and the hardness, ability to sustain their high temperature, ability with to withstand limit ceramics is approximately 1500 degrees Celsius, and chemical resistance to change and having to low density are a major benefit of this ceramics matrix composite. The strengthening of the ceramics is fiber made of materials such as the silicon carbide, carbon, and increase the fracture toughness. Okay. Next, the classification of natural fiber. Before classification, you have one and two points based of the natural fiber composite materials discussed. One of the biggest success of the materials history of the evolution of the composite materials and its design and process of this manufacture by the strengthening of this natural fiber throughout the recent decades because of the benefit of this natural fiber compared to the traditional glass carbon fiber, such as a less cost, low density, equivalent to specific tensile behavior, non-abrasive skin in critications, less energy consumptions, low health issues, okay, biodegradability, etc. Focus the researcher and scientists to think over naturally available fiber like banana, flax, jute, carbon, scissor, coir, etc. The type of natural fiber, the natural fiber can be easily extracted from the resource in the nature, which are widely available. The natural fiber possess some extraordinary material properties such as the capability to being decomposed by the biological activities, economical per unit volume productions, high strength, and specific stiffness. Composite having natural fiber as a reinforcement appear to the various distant garnished features over the synthetic fibers. They are low in weight, low in cost, and the less toxic, more environment friendly, and easily to recycle. These advantages make the natural fiber composites popular in modern applications over the synthetic fiber reinforced composite. The natural fiber composite material is classified into the main three categories. First is the plant fiber, and second one is the animal fiber, and the third one is the mineral fiber. The plant fiber, such fiber mainly consist of the lignin, hemicellulose, and cellulose. Okay, generally six type of plant fibers are available. Okay, the first is the bast fiber. This fiber is the incredibly important in the plant fiber category. Outer part of this plant stems are generally used for its extraction. Okay, the some carbon blast fiber are jutes, flax, abaca, and kenaf. Okay, the bast fiber are extracted by the possess both of the rating. The fiber extracted from best fiber is long with high tensile strength. This traditional use in this production of the tensile rope and sacks, etc. Okay. Next, leaf fiber. Leaf fiber is achieved from the leaf tissues in two steps. First step is the mechanical extraction um, and rating process, followed by the hand scraping. These are the hand and coarse fiber which possess high strength. Only leaf fiber is used for making a ropes, seats, wooden floors, and mats. Okay, the sisal, uh, kiroa, and henicune pineapples are some type of example of the leaf fiber. Okay, next, seed fiber. The common example of seed fiber is coir fiber or cotton. Okay, these are the extracted from the coconut husk. Seed fiber and coir fiber is generally lightweight and strong. The main applications are making of mat, brush, ropes, and stacks, and etc. Some common example of seed fiber are cotton and kapok, etc. Next is the fruit fiber. The fruit fibers, one of the strongest fiber extracted from the fruit from the plants. These are many types of fruit fiber which exist in the nature. Some important fruit fiber are bruceous fruit fiber, coir fruits, and betel nuts fiber, etc. Next, food wood fiber. Wood fiber have been extracted from the various trees present across the world. Generally, the wood fiber are divided into two categories. First is the soft wood, and second is one is the hardwood. The main distinguished features between these two classes in it is length, and hardwood fiber are generally sorted than softwood fiber. Okay, and the number of fiber is given gram of pulp, and hard and wood pulp is the significantly higher. Okay, the glass fiber. Some common example of the glass fiber are bamboo, elephant grass fiber. Some common example of the grass fiber of the bamboo, elephant grass, switchgrass, etc. These are the sources of the grass fiber and available in the tail grasses. There are the various methods of the extracting of the fiber from the grasses, such as the mechanical grinding method, chemical grinding method, or manual mechanical separations method. Okay. Next, animal fiber. The various type of animal fiber are available in the nature. Most common example of the animal fiber are wool, silk, hair, mohair, and alpaca. And hair generally contains protein. Okay. Next, mineral fiber. The mineral fibers are collected from the natural resources. There are the various type of mineral fibers used, such as a asbestos type, hematite, and chromodislite, ceramics fiber, or metal fiber. It may be occurring directly and the slightly modified fiber procured from the minerals. Okay. These are the plant fiber classification. The natural fiber eliminated the need of the man-made fiber, that is glass, carbon, mostly due to the given of this reason. The natural fiber reinforcement composites are being developed rapidly as compared to the synthetic reinforcement composite. They possess advantage by the being uh, profitable and due to their availability, low cost, eco-friendly nature, easy degradability, lightweight, high specific strength, easily achievability, and corrosion-free properties, and so many advantages of this type of fiber. The natural fiber is most advantage of this type of fiber. Use of this type of fiber is recyclable and fully biodegradable. Okay, but man-made fibers is not possible to the recycle and the degradable. Okay. The natural fiber consists of the cellulose, new cellulose. The natural fiber consists of the cellulose, hemicellulose, lignin, uh, pectin, wax, and a volume of water. Internal structure of this natural fibers are affected by climatic conditions and degradations process and age. The factor affecting of the mechanical behavior of the natural fiber are cellulose has proportionate influence the tensile test. The lagging has proportionate influence of the stiffness. The angle of helix axis of fiber has inverse influence on the tensile strength. The hemicellulose, pectin, wax, and the geometry of the elementary cells. The chemical components are scattered or over the cell wall, consisting two layers of the membranes, primary and secondary. And again, there are three layers of the secondary walls from the sequence of microfibrils, helical wound of the compromised by the middle thick layers, as shown in this figure. Okay, the microfibril are helical wounded, and its contents amorphous parts in between their amorphous phase consist of the mostly in the lignin and the hemicellulose. The chemical compositions change from the one plant to another, and different part of the same plant is also different. Okay, this is essentially the cellulose, hemicellulose, and lignin contents are basic parameters of natural fiber, and their properties vary from fiber to fiber. There are many advantages of a natural fiber composite. Some important advantage mentioned here, but not limit to the is the biodegradable, low cost, lightweight, low density, reduce low wear, corrosion resistance, easily availability, and the in the application of this automobile application such as a door panel, floor light frames, etc. These are the some more application. Material and methodology. The ripe bruceous fruit fibers are used for the extractions of the bruceous fruit fiber, this short form of the BFF. The bruceous fruit fibers extracted from their fruits were collected from the Polymer plums tree, which are abundantly available in this all over the world, especially in India. The bruceous fruit fiber was extracted manually. The ripe fruits are left submerged in the water from a week for a week, and after black skin of the bruceous fruit fiber fruits was removed, and the flesh attached with the fibers accumulate water, which results in extraction of the same. Therefore, the fruits were then the drawing of the water when the washed fully to eliminate the rust flesh, to remove the rust flesh completely. After that, the fiber was cleaned and dried under the light. When fiber were the dried and hot air oven at a 100 degrees Celsius for 5 hours, so that a remaining moisture may be removed from the fiber. Okay, this is the chopped fruit fiber, and this one is the epoxy, and this box is the hardener. Type of surface modification of natural fiber. Basically, three types of modification. First is the chemical modification. Third one is the physical modification, and second is the physical modification, and third one is the biological treatment of the natural fiber. First, chemical modifications of natural fibers are performed to improve the adhesion bond between the matrix and the fiber. There are some chemical modifications which could lead to reduced water absorption of natural fiber and their composite. Due to the chemical reasons that occur during the modification process, chemical compositions of natural fiber chain, that is hydroxyl group, get removed, okay, which increase the bonding affinity between the matrix and fiber, and the result strength of the composite gets improved. Okay, next, physical modification of the natural fiber. The physical modification alter of the structure and surface properties of the natural fiber and impact the mechanical bonding of this fiber and matrix fiber and matrix. And the physical treatments have no significant influence of the chemical composition of the fiber. Okay, the all types of physical treatment like plasma treatment, corona treatment, ultrasonic treatment, and ultraviolet treatment, etc., are reducing the hypothesis group present in the natural fiber. Last one is the biological treatment of natural fiber. In this type of treatment, the surface of natural fiber is modified by the biological process. Okay, the bacterial cellulose is deposited on the natural fiber surface, resulting in the substance enhancement of the boundary adhesion with the polymetric matrix and fiber. Okay, next, chemical treatment. The alkali treatment of bruceous fruit fiber. Alkali treatment is one of the most widely used for the natural fiber treatment. The efficiency of alkaline treatment of the natural fiber mainly depend upon types of alkaline solutions, its concentration, and the time of the treatment, and the temperature used of the treatment. Okay, the alkaline treatment improve the result due to the loss hydrogen bonding of the network structure, and thus resulting in increase the surface roughness. Okay, this approach eliminates some quantity of wax, lignin, and oil that cover outmost surface of the fiber wall. Okay, in the present experiment work, dried bruceous fruit fiber were treated in the presence of sodium hydroxide NaOH at 4, 8, and 12 percentage weight percentage. Okay, various NaOH concentration, hence therefore in the present research used in this type of solution, NaOH concentration solutions. for 8 hours at room temperature and 18 degree Celsius. Okay, the atmospheric pressure is approx 1013 mbar equivalent to 1013 mbar equivalent to 1,1300 Pascal. Okay, and the humidity approx 66%. Okay, the next treatment is benzolation treatment. Benzolized chloride has been mostly or commonly used for during fiber treatment. Benzoyl treatment is chemically name is the C6H5COCl, which reduce the hydrophilic strength of the treated fiber and thus improve the fiber matrix interfacial adhesion. Okay. In benzolation treatment, initially bruceous fruit fiber treated with 8% alkaline solutions for the 30 minutes to active hydroxyl group, and after that alkali treated bruceous fruit fiber dipped in benzyl chloride solution for 15 minutes. Okay, and shown in this figure number B. The further benzylation treated bruceous fruit fiber was cleaned with ethanol solutions to remove the benzoic acid, and finally cleaned with the distilled water for multiple time. Third treatment is the acetylene treatment. The acetylene group interact with the fibers hydroxyl group and eliminate the residual moistures. After that treatment of the natural fiber with acetylations and hydrophilic nature of the fiber is reduced while improving the dimensional stability and fiber dispersion into the polymetric materials. For acetylation treatment, bruceous fruit fiber was dipped in initially 8% alkali solutions for 30 minutes. After that, washed with the distilled water and then neutralization with 2% hydrochloride, then dried in the oven hot air at 80 degrees Celsius for 4 hours. Okay, and dried and alkali treated bruceous fruit fiber dipped in acetyl chloride solution for 15 minutes at normal temperature, room temperature and pressure. Okay. Next, development of and fabrication of composite material. The traditional hand layer method was followed to fabricate the composite specimens developed my PhD student. The bruceous fruit fiber and epoxy resin were considered as a reinforcement and matrix for the fabrication of composites. The low curing temperature resin was used LY556 and recommended hardness used based off the previous paper HY951 were mixed with the help of electrical and where the mixed electric binder and ratio of this 110 parts of weight of direct by the supplier in order to the obtain of the homogeneous mixture in resin and hardener, okay, respectively. The rectangular mold dimension is 180 into 170 and thickness is 5 mm. Was filled with calculated amount of raw and treated and untreated short bruceous fruit fiber with different weight percentage into the mixture of epoxy resin and hardener and mixed properly to obtain substance compositions. Then mixture the matrix and fiber is poured into the mold. Okay, the dimension and length of the bruceous fruit fiber chosen for the purpose of the fabrication and for composite are a range of 0.1 to 2 mm, and the dimension and length is 5 to 4 to 5 centimeter. Okay, and the fiber and resin were uniformly distributed in the mold uh, up to the required thickness, and dead weight of 50 kg was applied to top of the mold to uniform wetting. Okay, after that dry composite plate has been removed from the mold, and then specimen were cut based on the ASTM standard. Okay, these techniques was used to prepare 5, 10, 15, and 20% bruceous fruit fiber reinforcement uh, uh, reinforced epoxy composite slabs. Okay. Next, result and discussion. The effect of uh, alkali treatment NaOH of water observation behavior developed composite. The water observation behavior analysis was performed in the presence of Ganga water, distilled water, and tap water. The weight gain by each specimen was measured at regularly time interval of 12 hours. Okay, and the water observation test was performed for the 300 hour at water observations, which formula is final weight minus initial weight divided by initial weight into 100. Okay, in this figure, first figure A shows the clearly shows the 4% NaOH treated bruceous fruit fiber based composite had more water observations, approximately 6 to 7% as compared to untreated bruceous fruit fiber. Okay, the water observation by the 8% NaOH treated bruceous fruit fiber uh, is relatively low as compared to 4% NaOH treated and untreated bruceous fruit fiber composite. The dust particles and unwanted substance present in on the surface of the fiber was removed, which made of the hydroxyl group directly come in the contact with the water. Okay, this result in the result of the in the water water absorptions for the composite specimen fabrications with 4% NaOH treated bruceous fruit fiber. In 8% NaOH treated bruceous fruit fiber composite, the hydroxyl group of hemicellulose, lignin, and uh, patin gets removed from the fibers, which are the main causes of the decrease of the water observation. In 12 NaOH treated NaOH treated fiber based composite, some part of cellulose of bruceous fruit also get removed in the NaOH solution. The water observation the water observation for 4% NaOH treated bruceous fruit fiber is increased and then decrease. Therefore, uh, thereafter, with a further increase in the percentage of NaOH when the composite specimen are exposed to tap and distilled water, whereas a maximum water observation tendency was observed, then the composite specimen are treated with the 8% NaOH and epoch of the Ganga water. The effect of NaOH treated on surface of fiber. The surface of the fiber is found to be moderately rough and cleaner due to the fact that of the hemicellulose of removed whenever the fiber are treated with 4% and 8% NaOH. The treatment with the alkaline has initially two affected on a fiber surface. It removed the surface roughness, which result in good interfacial adhesive bonding between the fiber and matrix. And second one is the destroy the sum of lignin wax oils on the fiber external surface. Okay. In case of 12% NOS treated fiber, the surface of the fiber extremely rough because some part of cellulose are also removed during the treatment of fiber, which results in breaks of the molecule um, structure of cellulose. Next is the effect of the alkaline treatment of the properties. The 8% of NaOH treated bruceous fruit fiber based composite shows the maximum strength and modulus of compositions of untreated 4% and 12% NaOH treated bruceous fruit fiber, but further increase the percentage of NaOH 12% for purpose of treatment result is decreased strength and modulus. In 8% NaOH treatment, some of the hydroxyl group get removed, resulting in increased strength of the composite is in composition of 4% NaOH treated and untreated fiber composite. But in case of 12% NaOH treated composite, all hydroxyl group and some part of cellulose also eroded and resulting in the in a reductions and the tensile strength in composition of 8% of NaOH treated fiber, reinforcement fiber. The effect of NaOH treated on fractural strength of developed composite. The 3 points bending test were conducted to determine the fractural strength of untreated and treated bruceous fruit fiber. The fractural strength of chemically treated bruceous fruit fiber composite were found to be superior to those made from the untreated bruceous fruit fiber. The fractural strength of the fractural modulus for the bruceous fruit fiber composite with governed with the 8% NOH is maximum is comparison to untreated 4% or 12% treated. The surface roughness of chemically treated bruceous fruit fiber increased due to the removal of unwanted clumps, wax, hemicellulose, etc. The effect of NaOH treated on impact strength of the developed composite. Both Charpy and Isol analysis were carried out to investigate the impact energy of the chemically treated and untreated bruceous fruit fiber composite. It is clearly indicate in this figure that 8% alkali treated bruceous fruit fiber composite has relatively more strength than the untreated 4% and 12% alkali treated bruceous fruit fiber. Both in both case, Charpy and Isol. It is also clear that the alkali treated fiber contribution of this better impact properties as compared to untreated fiber reinforced composite. The maximum impact strength was observed when the treatment of fibers is carried out at moderate concentration, 8% NaH. The surface morphology of treated alkaline, benzene, and acetylene and untreated bruceous fruit fiber. In this same image is used for study. Scanning electron microscopy is used for the study of surface morphology of bruceous fruit fiber after influence of the various chemicals on the surface. The acetylene treated bruceous fruit fiber shows the maximum surface roughness as compared to other treated and untreated bruceous fruit fiber. In acetylene treatment, the bruceous fruit fiber is first treated in alkaline solution, then fibers underwent acetylene treatment. Then hemicellulose and impurities present in this bruceous fruit fiber are eliminated during the alkaline treatment. When the the hemicellulose and impurities are eliminated by the acetyl chloride through the um, solvent solutions or actions. Thus, higher roughness of fiber and improving fiber matrix bonding is achieved. And the mechanical analysis like tensile, fractural impact is significantly improved when epoxy is reinforced with the bruceous fruit fiber as compared with untreated bruceous fruit fiber based composite. The tensile and fractural properties of treated bruceous fruit fiber composite are systematically improved. Okay. In next slide is tensile properties of treated based on the alkaline treatment, benzoyl or acetylene treated or untreated bruceous fruit fiber composite. In this um, graph shows the tensile strength has been increased by approx 7 to 8% in case of NaOH treated and 16% in case of benzene treated and 30% in case of acetylene treated based composite when compared to the untreated. Similarly, the tensile modulus has also been increased by 18% of case of NaOH treated and 60% in case of benzene treated and 67% in case of the acetylene treated based composite when as compared to the untreated uh, bruceous fruit fiber composite. The chemical treated results in the superior fiber matrix bonding as the hydroxyl group is removed from the bruceous fruit fiber. Due to the acetylene treatment, the surface of the fiber becomes rough as it's removed most of the hemicellulose and lignin and hydroxyl group present in the fiber. The acetylene treatment will eliminate the hydrophilic aspect of the bruceous fruit fiber and improve dimensional stability of the resultant composite. Like the fractural properties of treated alkaline benzylations and acetylations and untreated bruceous fruit fiber composite. This analysis shows that now the fiber treatment has a significant effect on the fractural properties of the composite. The tensile strength and the modulus obtained under the fractural loading are quite low for the untreated bruceous fruit fiber composite as compared to the treated composite, bruceous fruit fiber composite. Whereas benzylation treated composite shows more strength and more modulus as compared to alkaline treated composite. This may be credited to the improve the bonding between the treated bruceous fruit fiber and epoxy matrix, which subsequently results in more fiber matrix interaction. Okay. Next Impact properties of treated alkaline, benzene, and acetylene and untreated process fruit fiber composite. In this figure shows the variation in CHRP isol impact strength of the untreated and treated crucius fruit fiber composites are indicated in this figure A and B. The impact strength of this chemically treated crucius fruit fiber is superior to compared to the untreated crucius fruit fiber. The acetylation treated composite show the maximum impact strength in both CHRP 15% and isol test in 37% approx, which are the higher than the untreated composite. The micro escape that is indicate that the microescape that the indicate that the interface resulting in cracks propagations as a impact load is applied to the composite specimen. These subsequently result in reduced impact strength of the developed untreated composite. Micro hardness analysis of treated alkaline regenerations and acetylation treatment and untreated composite. The indication load is applied perpendicular to the composite plates to study the micro hardness properties of the developed composite. Weaker hardness number is presented beyond the depend of the previously applied minor load by the penetration of the test wall to the additional depth of the measured load. The high hardness number represent the hard materials and the less penetration of the indentations, while low hardness number is mean for the relatively softer materials as compared correspondingly more penetration in the indentations. The neat epoxy achieve the highest hardness value that untreated crucius fruit fiber composite were given with the 26% hardness micro hardness value, which is 13%, 22% and 23% approx higher than the micro hardness value of NaOH treated and benzene, acetylene and brucous fruit fiber epoxy composite, okay, respectively. This is because of the fact that the brittleness of the composite decreases and the ductility increased due to the chemical treatment of the fiber. Water observations properties of treated alkaline, benzene, acetylene and untreated crucius fruit fiber composite. It is clear for this
Hello. 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 Abhishek sir. Hello. Hello.
Sir, I think network problem, sir.
Just I'm calling. Just wait for 2-3 minutes. Sir will reconnect. Dear participants, some technical issues comes, so sir will rejoin. So wait 1-2 minutes. One minute for the recording, sir. Okay, sir. Recording will start.
My PPT is visible?
Sir, your screen is visible, sir. PPT is not coming.
Okay.
Yes, sir. Visible, sir.
Okay. This is the video graph of the fabrication of the composite material by using hand layer process developed by my PhD student Dr. Kumar. Water observation properties of treated based of the alkaline benzylations and the acetylation and untreated Bruceus fruit fiber. In the I have already discussed and in the all the chemically treated fiber, acetylene treated Bruceus fruit fiber based composite shows the minimum 2% water observations followed by the benzylations in approx 2 to 3%, and alkali treated Bruceus fruit fiber composite is 3 to 4 percentage. Okay. Next, influence of fiber weight ratio on the tensile test and modulus. The tensile strength of developed Bruceus fruit fiber epoxy composite with different weight percentage 5%, 10%, 15%, and 20% of fiber was used. And so in this figure A and B, that Bruceus fruit fiber weight ratio increases the tensile strength and modulus increases up to 15% weight ratio. Further increase in weight ratio of Bruceus fruit fiber above the 15% decreases the same because of the storage of resin materials due to the lower interfacial adhesion among fiber and matrix. The Bruceus fruit fiber composites of 15% fiber weight ratio obtained 51% and 165% higher tensile strength than 5% and 20% weight ratio of Bruceus fruit fiber respectively. Similarly, 51% and 240% higher tensile modulus were obtained 15% weight ratio composite as compared to 5% and 20% weight ratio of Bruceus fruit fiber composite respectively. In the case of fiber weight percentage of 20% in tensile strength is approximate 20 megapascal and tensile modulus is 3 gigapascal decreases suddenly because of more weight percentage of fiber as compared to resin. Okay, in this case the fiber cannot get weight and resin cannot reach every position of the fiber and cannot form proper interfacial adhesive bonding between the fiber and matrix. The influence of fiber weight ratio on fractural strength of modulus. In this figure, indicate that the fractural strength and modulus increase with a resin in fiber weight ratio up to 15% after the again, yes, again rising the fiber weight ratio decreases both the fractural strength and modulus because of poor wettability between fracture Bruceus fruit fiber and epoxy. The optimum value obtained or for the fractural strength 39 megapascal for 15% weight ratio of the fiber, which is 17% and 46% higher than the 5% to 20% weight ratio of fiber composite respectively. The maximum fractural modulus 4.5 approximate gigapascal was noted for a composite reinforcement with 15% fiber weight ratio, which is 42% and 76% higher than 5% to 20% fiber weight reinforced composite respectively. The minimum value of fractural strength is 26 megapascal and fractural modulus is 2.6 gigapascal obtained from the 20% weight ratio of the composite. Next, influence of the fiber weight ratio on impact strength. The impact strength improves with increase the fiber weight ratio and followed the some trends as compared to other properties. Maximum impact strength obtained for the fiber weight ratio 15% and after that further increase the weight ratio of fiber impact strength decreases. The value of the maximum impact energy achieved for the Charpy test was 3 joule for 15% weight ratio of Bruceus fruit fiber. The minimum Impact energy for CHRP and isol test was noted to be 1 joule or 0.54 joules respectively in case of 5% weight ratio of Bruceous fruit fiber epoxy composite due to the more amount of matrix as compared to fiber, resulting into the fabrication of this more brittle composite in nature, and therefore less amount of energy was consumed as compared to 10% and 15% weight ratio composite. Next, influence of the fiber weight ratio on micro hardness. The weaker hardness testing machine was used for perform micro hardness testing. This test was performed on 5 different points on each specimen, and average value was taken into consideration. This figure indicate that the micro hardness increases with the rise of weight percentage of Bruceous fruit fiber up to 15%, and later rise the weight percentage of fiber reduce micro hardness. The maximum hardness value obtained in the percentage investigation is 19, okay, for 15% weight fiber ratio composite, which is 55 and 11% higher when compared to 5% to 20% fiber weight percent composite respectively. The minimum value obtained was 12 hardness with 5% fiber weight ratio. Next, influence of the fiber weight ratio on water observation behavior. This figure indicates that the water observations continuously improve with the rise of fiber weight ratio. The water observation percentage regularly increase with the rise in the time period up to saturation point. After that, water observation rate becomes constant. In figure number 27, this representation of this figure, that is the maximum percentage of water observation for composite, was seen with 20% fiber weight ratio and minimum of 5% weight ratio of Bruceous fruit fiber composite. The main cause of this increase of the water absorption with fiber weight ratio is due to the Bruceous fruit fiber hydrophic nature. Okay. In case of 20% fiber weight ratio, composite hold maximum hydrophilicity and allowing the more water observations. The percentage of water observation improving with rising fiber weight ratio due to the hydrophilic nature of the natural fiber. The FESM, field emission scanning electron microscopy analysis of tensile fractured surface. The surface morphological studies in this analysis, the fracture surface of tensile, fractural, and impact test specimen for different weight ratio of Bruceous fruit fiber and force composite. Figure number 28 denote this pictures of tensile fracture specimen. Hello, बस सर 15 मिनट में आ in figure number 28 A and B, it appeared that matrix is getting cracked because of only 5 attribute to poor Bruceous fruit fiber distribution, and due to this reason gaps are found between the matrix and fiber, and failure were noted in this matrix. Okay. In 15% Bruceous fruit fiber weight ratio, as increased the tensile strength was found as a result of a strong bond between fiber and matrix, as the crack could not propagate freely due to the uniformity of the fibers in every direction, and the fiber were able to bear the load. Okay, in figure 28c, so that the fiber breakage take place as a result of the stronger bond at a interfacial surface due to the this reason 15% Bruceus fruit fiber composite were found best among all. Okay, and figure 28d void are clearly seen due to the fiber pull out because of 20% Bruceus fruit fiber composite, since fiber is more and resin is less. Because of this poor interfacial adhesion with of the matrix, and the clustering of this fiber results and turn into the corresponding decreases the mechanical properties of composite. This analysis of fractural uh, fracture surface. This FESM analysis of fractural surface of fractural test specimen. In this test, matrix breakage, fiber breakage, and fiber matrix debonding were observed. If Bruceus fruit fiber weight percentage increases when voids were made due to the fiber pull out because of weak adhesion between the fiber and matrix. During the fractural test, Bruceus fruit fiber get pulled out from the matrix because of the poor adhesion, resulting in the formation of the void in 20% weight ratio of Bruceus fruit fiber composite sheets. During the bending load, the cracks were formed near the void region of the specimen. These cracks started propagating as soon as applied load starting acting on the fractural test of the specimen, and the test failure of the composites occurs. This is the last slide of presentation. The field scanning electron microscopy analysis of impact fracture surface. The figure 30 shows indicate that this scanning electron microscopy surface morphology analysis of the fracture surface of impacted specimen. In this test, the fiber matrix beyond debonding and the fiber breakage were observed. During the impact test, as the certain load is applied on the nose specimen, crack being a propagate throughout the specimen in 5% Bruceus fruit fiber composite because fiber is less as compared to matrix. In 20% Bruceus fruit fiber composite, fiber pulled out, the fiber matrix attachment cannot make a significant contribution to the energy dispersion during the composite fractures. During load operation, fiber could be easily removed from the matrix, resulting in the weaker strength transfer, resulting to the low impact capacity. The following conclusion can be drawn from the presentation. The successful developed of the Bruceus fruit fiber reinforced polymer composite in NIT Patna house, developed by the Dr. Nitish Kumar, and the mechanical properties such as tensile, fractural impact are significantly improved when the epoxy is reinforced with the Bruceus fruit fiber. The alkalinely treated Bruceus fruit fiber exhibit better properties than as compared to untreated Bruceus fruit fiber. The better mechanical properties were obtained when the treatment of the fiber is carried out and at a moderate concentration of NaOH 8%. Okay, the percentage of chemical. The same analysis confirmed that the surface of a fiber becomes rough as the fiber is treated with the chemical, and thus the fiber matrix bonding is improved. The acetylation treated Bruceus fruit fiber shows the maximum surface roughness as compared to other treated or untreated Bruceus fruit fiber. The tensile and fractural properties of the treated Bruceus fruit fiber based composite are significantly improved as compared to untreated Bruceus fruit fiber based composites. The acetylation treated Bruceus fruit fiber based composite exhibit maximum tensile and fractural strength and modulus than as compared to untreated benzolations and acetylene treated composite. The hardness of this untreated Bruceus fruit fiber based composite is superior to the chemically treated Bruceus fruit fiber composite. The alkaline treated Bruceus fruit fiber based composites shows the highest hardness value as compared to other chemically treated Bruceus fruit fiber based composite. The water absorption tendency of this developed composite increases when the composite are fabricated with the chemically treated Bruceus fruit fiber. The chemical untreated Bruceus fruit fiber based composite shows the maximum water absorption tendency, whereas the acetylene treated Bruceus fruit fiber based composite shows the minimum water absorption tendency. The mechanical properties such as tensile strength, modulus, fractural strength, and modulus impact strength, hardness, micro hardness were obtained higher for the 15% Bruceus fruit fiber composite as compared to other one. The water observation behavior regularly increases with the increase in Bruceus fruit fiber weight percentage. Okay, and field FESM image of tensile fractural fractures surface highlighted the fiber pull out voids, matrix cracks, fiber breakage, fiber clustering, etc. And last conclusion of this PPT, the mechanical properties and water absorption behavior significantly depend on the Bruceus fruit fiber weight ratio. Thank you all. These are the references which is used in the PPT. Thank you.
Thank you very much, sir.
Thank you.
Dear participant, sir have some other meeting, so that's why sir already told that if any query, you text the chat box. I send to the sir, or if in this meeting, Dr. Nitish Kumar is also there. So if any query, so we can ask question to Dr. Nitish Kumar. And sir, first we thank to the sir. So thank you, sir. Thank you so much for the informative lecture, sir. So I request to Abhishek to
Yes, sir.
conclude the sir's sir presentation.
Sir, on behalf of all the coordinator, myself and participant, I would first like to extend our sincere thanks for the sparing your time from your busy schedule to provide a valuable information for us, sir. Thank you very much, sir.
Thank you, Abhishek. Thank you so much.
Okay.
And whatever
Yes.
any query and questions of the participants, please send me a mail. Okay, abhishek.singh@nitp.ac.in. Okay.
Okay, sir.
Okay. Thank you so much. Thank you, Sabin.
Yeah, thank you, sir. Thank you so much, sir. So Dr. Nitish Kumar is there?
Yes, sir. I'm here, sir.
Yeah. So some students, some query related to this one question from Piyush Kumar Pathak. So my question, he write, my question is the natural fiber has different properties than natural fiber have. How it allow ASTM testing? Hello.
Yes, sir.
Mr. Piyush Kumar Pathak have some. He writes some question.
So Piyush Kumar Pathak is here. Piyush Kumar Pathak is here. So I think Piyush Kumar is not here, sir.
Yes, yes.
So okay, I told that the ASTM is the American Society for Testing and Materials. According to ASTM standard, the size of the natural fibers reinforced polymer composite is design the a specimen for the different types of the testing, like the tensile test, flexible impact test. For tensile test, I have taken the ASTM D638 of the grade. The size of this ASTM for tensile testing is taken to know the length of the specimen is 165 mm, and the width of the specimen is of 20 mm, and I've taken the dogman shape. So arch of angle of radius of the dogman shape is the 15 mm, and the gauge length I've taken the 100 mm. But the thickness of the materials is restricted from the only 5 mm, not more than the 5 mm or below the 5 mm. But due to some extent, the thickness of the materials may be the from the 1 to 0.1 millimeter to 1 mm. 1 mm. So here the thickness try to take in the thickness of the 5 mm only. So this is the ASTM for the natural fibers reinforced polymer composites. But the different materials can be the change the ASTM standard. Okay. In case of the for impact test, I have taken the ASTM D6110. Okay. And for flexural test, I have taken the ASTM D790. In this is the specimen size of the flexural test is the 100 mm length and 20 mm width. The thickness is the again 5 mm. So any query again, sir? Anyone?
Okay. So, dear participant, if any query related to the natural composite in Bruce's fruit fiber, so please ask. Hello. Okay. I think there is no query. Thank you, Dr. Nitish Kumar.
Thank you.
And,
Thank you so much, sir.
So, dear participant, after lunch, we take that means we meet 2:15. So our last technical session of that today is 2:30. Start from 2:30 p.m. So our next speaker is Dr. Sarabjit Singh sir, and so we meet 2:15 for the third technical session. So okay, so we meet 2:15 p.m. at this platform. Okay, thank you everyone.
Thank you, sir. Thank you.
Thank you, sir.
Feedback form already sent in chat box. Feedback form of second technical session already sent in chat box. Hello.
Yes, okay, sir.
Okay.